Check, 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 check.
Hello, good morning. So I'm going to do the opening remarks. Thank you so much.
Hello.
Can you hear me? Okay, seems like. Okay, sorry about that. Good morning, everyone, and thank you so much for joining us today. Welcome to the day 2 of the Improving Scientific Software Conference. Thanks for both of you joining us online and also the folks that are joining us in person today. We have an exciting day ahead, a lot of exciting talks, but before we begin, here are some important reminders and updates. So for folks in person, if you have any questions during the session or after the sessions, please remember to speak up in the microphone or close to the microphone so our virtual attendees can hear that, your questions. Our Zoom chats should be off, so we are using Slido for questions, and any AV issues, please post them on Slido because our Zoom chats are off. We also have a Slack channel that we use for communicating with our participants. And also during out the year, there are other events from the SEA or Software Engineering Assembly that we hold, and we advertise them in our Slack space. This year we have some social meetup time slots that we are doing this year for test. I don't see Daniel here, but Daniel is organizing that, and please feel free, there is a Google Sheet for that. Please feel free to check that out and check our Slack before heading to any of our breweries or any of the restaurants that we have planned for the social meetups. Don't forget that we have some topics for voting for the Wednesday networking session. I saw that a lot of you actually voted. So there are a lot of interesting topics. Please feel free to vote on what you'd like us to cover in this networking session and the themes of the networking session. And another reminder is that we are doing notebook proceedings this year for the ISS conference. This would help us kind of have that flexibility of adding code and images and a lot of interactivity for some of us that are developing, for example, Python packages. But if you have your proceeding and your work in other formats, we'd be happy to help you with converting those to notebook or markdown format. We have detailed instructions for adopting our template for your paper, and all the proceedings will be published through Jupyter Book. Again, we have office hours that you can join if you have any questions about the notebook proceeding, or if you need any help with converting your files to the format that you want, or yeah. And last but not least, thanks so much to Sam, Lisa, Carol, and our fantastic multimedia services for helping us today with and during out the event for everything actually, and organizing this event and helping us with the success of this event. With that being said, let's get started with our first invited talk today, Dr. Romit Maulik. Dr. Romit Maulik is an assistant professor in College of Information Sciences and Technology at Pennsylvania State University, or as we know it, Penn State. He is also a co-hire at the Institute for Computational and Data Sciences at Penn State and joint appointment faculty at Argonne National Lab. He obtained his PhD in mechanical and aerospace engineering at Oklahoma State University. And today he's going to talk about automated deep ensembles with uncertainty quantification using DeepHyper. Romit, please feel free to get started. Thank you.
Hello, can you hear me?
Yes, we can hear you.
Yeah. So okay. So thank you for the kind introduction. I should warn you, I cannot really see anything but my screen. So if anyone wants to interrupt me, please speak up. I'm happy to take questions in the middle of my talk. It's a great delight to be there virtually. I wish I was there in person, but I'm on paternal leave this semester, and you might hear my daughter screaming in the background. So apologies in advance for that. Yeah, today I'm going to speak a little bit about some work that I did while I was at Argonne as a staff scientist, and I continue to collaborate with the team. The leadership of that team has actually moved to Oak Ridge National Lab, where we developed essentially automatic machine learning libraries for automating the process of neural network construction and for science applications. Right? So So I'm going to give you a little bit of math. I promise it's not a lot, but it's going to be helpful for you to follow along the software side of things. And the math is going to be based on basically very simple things related to machine learning. In this case, regression, right? Once we get through this, you will get an appreciation for why the automatic machine learning library that we constructed can actually be quite helpful to you in terms of your various applications, right? So let's say that we have a supervised learning problem with a particular data set. So you have some. Let me make my let me put in a laser pointer. So let's say you have some inputs X and you have some outputs Y, and you have a certain data set with n points. Assume these are I don't know, something like a regression problem, right? So rather straightforward. And they both the inputs and the outputs have a certain dimensionality. It could be images, could be time series data. It's agnostic to that. And our goal is to essentially fit a function f that approximates, or train a model f theta that approximates the underlying ground truth function f, which is inaccessible to us. This is inaccessible, so we want to learn it. We assume that the data has a little bit of noise, white noise. This is also going to become important in a bit. What we want to do is we want to predict this particular data set Y given a new query point X, but we also want to quantify uncertainty in it, right? So a lot of our software development actually is very intimately connected with the notion of quantifying uncertainty in deep learning. So this is important that we are able to quantify uncertainty during our machine learning procedure, right? And F over here, for this moment, let's assume it's a neural network. That's really where these things are very powerful, right? So in case you acknowledge the fact that your output has a certain white noise with unknown variance, then your loss function for training this particular neural network, f theta, is given not by simply a mean squared error. So you might think about regression in the sense of y minus f of x the whole squared, but it's a log likelihood formulation where you also have a dependence on this unknown noise, this variance sigma squared, right? And so what you would want to do in such a case is that you would want to have a model that predicts both f, or predicts the mean, and a model that also predicts the variance, right? So there are going to be two outputs of a model, even though your goal is to predict one output y. Okay, background information, it will become transparent soon why we need this, okay? Now, the idea of trying to quantify uncertainty requires you to understand that there are two different types of uncertainty, right? So the uncertainty I mentioned in the previous slide is something known as aleatoric uncertainty. And aleatoric uncertainty implies that you're dealing only with the uncertainty in the training data. So in this particular case, you knew that there was some noise during your measurement for the dependent variable y, and there was some uncertainty associated with that. So this particular formulation for one neural network would enable you to capture that uncertainty, right? But this is not all the forms of uncertainty that actually end up in your particular regression task. You have other uncertainties that are actually related to, for example, your neural network itself. So I'm sure all of you who have actually trained neural networks will know that when you change certain features about a neural network, for example, the number of layers and the number of neurons per layer, then you will get different predictions. And then that is kind of the uncertainty related to the architecture of a neural network. And so our goal is to also capture that. So there is a formulation used quite frequently in deep learning known as the deep ensembles formulation, where the idea is that you will train separate models. So for this particular task, you will train multiple different models, in this case, capital M, and you'll train them with potentially different random weights. There is a reason why you have to train them using the same optimizer, which I'm happy to clarify later. It's a theoretical reason. But the simple reason is that you kind of have different architectures initialized differently, potentially looking at different subsets of the data. but they are trained independently. They don't communicate across each other. And at the end of their training, you have M independent models that you can independently query, right? So each model will essentially give you its own variance and mean, just as I showed you in the previous slide. And then you can actually do what is called a complete quantification of uncertainty using the so-called law of decomposition of variance, which says that if the total uncertainty in your output, given that you have M independent models and each model can predict both the variance as well as the mean, is given by the aleatoric uncertainty and the epistemic uncertainty behaving additively. The aleatoric uncertainty is essentially the expectation of the variance, and the epistemic uncertainty is the variance of the expectation. So what that means is you take the variance of individual model predictions, M model predictions, the average variance of that is the uncertainty in the data, and vice versa. You can do the same thing, but now with the prediction of the means, and that is the uncertainty in the model predictions, right? So this is how you can, if you have the computational budget, you can train different independent models and get a full characterization of uncertainty in a regression task, right? And the the reason why this is quite popular is because there is a direct theoretical connection between deep ensembles and the concept of Bayesian model averaging, which says that, okay, if you want to fit like a Bayesian neural network or a Bayesian interpretation of a neural network where you want to compute the predictive posterior, which is you want to compute the probability of the output given an input as well as all your data, then you need to actually average over different model configurations. Theta over here are the weights, right? So, and this integral is something that you can discretize using quadrature. In our case, we've just used very simple Monte Carlo. Of course, we're not talking about convergence and whether this actually converges to something like this. That is beyond the scope of this discussion, but this is in practice what is used quite frequently, and ever since it was introduced in 2017, and with newer variants that, for example, me and my collaborators have introduced, we have seen that it actually outperforms other Bayesian neural network techniques such as Monte Carlo dropout or mean field approximations for Bayesian neural networks. And so on and so forth. So this is a very conceptually simple but computationally expensive approach to characterizing the uncertainty in a regression task, right? So now the motivation for developing the library that I'm going to introduce stems from both a mix of what I just introduced, the mathematical background, but also a fact that whenever you, or let's say people you are working with, have to train a neural network, you know that it is an arduous process when it comes to selecting the architecture, identifying the right set of hyperparameters. There are some empirical methods out there which can assist you with starting in a good place, but there is still a lot of trial and error that goes into it, which a lot of people call graduate student descent. You just give the graduate student an idea and ask them to see if they can use deep learning, and then they basically spend many months tuning things and burning GPU hours, right? So having a principal automated approach to constructing deep learning architectures is valuable, right? And so in this in this package that I'll introduce, we actually try to automate this sampling and search technique for hyperparameters, of course, assuming you have access to enough computing, right? And then the idea is that in our approach for sampling for architectures, we generate large populations of architectures, some of which are good, some of which are bad, of course. But you can construct ensembles from the sampling process. Let's say you've trained multiple architectures in parallel to not only get you a good neural network that gives you a good point prediction, but also then gives you a full characterization of uncertainty. So it reduces the sort of the cost hit of training multiple architectures all at once, right? Because you can get the uncertainty, get more for what you, right? And so the original paper on deep ensembles said that all architectures must be identical when you train it. So for example, going back to the slide over here, when we said that we need to compute the expected output given the input based on averaging across these different models that you've trained, then the original paper said all these models have to be identical. So basically, the only thing that changed was the initialization of the weights and parameters. In some work that was published a few years ago from with my collaborators, we actually generalized to situations where there may be a variety of neural architectures. So the members of the ensemble can be generated using different neural architectures. However, the space of neural architectures, even for a very low number of parameters, is very large. So that reinforces the need for having an intelligent search process. How do you search for neural architectures intelligently so that your ensemble is good individually? And then how do you create the ensemble out of these good models and quantify uncertainty? And so that brings me to the tool that I will kind of introduce to you today. This is the tool is called DeepHyper, which basically stands for deep learning hyperparameter search or hyperparameter optimization. It's really the driving force behind DeepHyper is Romit Maulik from Paris-Saclay, and actually this slide is outdated. He has now moved to Oak Ridge National Laboratory. Apologies for that. Because the leadership of the team has actually moved to Oak Ridge National Lab. That's Prasanna Balaprakash at Oak Ridge. And it has been deployed on several leadership class computing systems. So Frontier, I don't know if it's on Aurora yet, but definitely Frontier, it's on Polaris, it's on NERSC, so Perlmutter, and of course several campus clusters as well. So it's been quite successfully deployed on DOE systems for sure, but it's pretty easy to set up and use even on your laptops, for example. So several applications require hyperparameter neural architecture search. So as you can see over here, I work more on the geophysical surrogate side, and I'll have some examples from that. A lot of the material here is available on our GitHub, and then there's documentation that you can look at with tutorials and things. And so I will leave a link to that. I think it's in the abstract, but it's also in this presentation if people are interested. Right? So that's DeepHyper. And so now we can get started with the essential steps of doing something like a deep ensembles formulation with DeepHyper. The idea is to make certain. It's similar to other hyperparameter optimization packages that are out there. If you have a subclass of a neural network architecture module, whether in TensorFlow or PyTorch, my examples are PyTorch, that can be adjusted on the fly. So you can build new architectures on the fly given queries from an optimization from a search. Then DeepHyper can basically use this to perform intelligent sampling in that high-dimensional search space. So this does not have to be a neural network. This can be a Gaussian process. This can be a linear regression. This doesn't even have to be a regression problem. So this, divorced from the idea of deep ensembles, you can actually use DeepHyper to do Bayesian optimization of any parametric sort of process, right? So for example, let's say that we set together a subclass of a neural network in PyTorch where we have variability in the number of layers, number of units per layer, activation functions, dropouts, and so on. So you can, for example, provide a keyword such as what type of activation to use, what dropout rate to use. So dropout is kind of for regularization. And the number of units to use, so number of neurons in a particular layer, then these can be passed in as arguments into the class object, and then generate new neural networks, right? So just to follow up from our mathematical background, our goal is to quantify uncertainty both in the data as well as the model. So assuming you have a subclass that is able to generate neural networks, then these individual neural networks should not only predict a mean, which is f theta, but it should also predict a variance, which has to be positive, right? So this is, like a design that you have to build into your neural network. Of course, if your neural network is working on images, then you have to make sure that you are able to stay faithful to the output. So there has to be a mean and a variance that is designed, that is available at each pixel in your image. In this case, we are just talking about a scalar or a simple regression problem. And of course, these mean and standard deviation outputs share layers which come from the main neural network backbone, right? So just something to make sure that you get aleatoric uncertainty. And the main approach to how you might expose this adaptive neural network generation of object is through this HP problem class, which comes in DeepHyper. You define an object from this class, and then you can essentially add the various things that you want to tune. You want to add a hyperparameter related to the number of layers, and that can be set between a certain range. These quantities can be integer, they can be real valued, they can be selected from a list. So there's all these options that you have to add these hyperparameters, and of course you can control how they can be used. So for example, over here, for our particular example, we say that we want to select the number of layers in our neural network. We want to select the number of units in our neural network. The number of layers is set between this limit. The number of units is set between these limits. These are both integers. And then we can also say for each layer, we want to set the specific activation function, which is set from a list. So here it's not ordered, it's categorical, right? You can also set default values. Dropout rate over here, which is a real valued number. Here you can this is, so it's basically you can have mixed integer type setup, right? Other things you can do is you can actually have these adaptive relationships between hyperparameters. A simple example of this is in these lines over here. It's available using this greater than condition. It's just a conditional statement. You can design your hyperparameter selection in such a way so that the search space is sensible. For example, if the max number of layers is set at a certain value, and let's see how I can explain this. So if the number of if you have set a certain max number of layers and you have decided that you want to add hyperparameters to each of the layers, but your hyperparameter search says that the max number of layers is a value 4, which is much less than the maximum, then hyperparameters beyond layer 4 are inactivated, right, or deactivated. So it's adaptive in such a sense, right? So you can make sure that if a certain hyperparameter configuration is activated, then other hyperparameters can be immediately determined in relation to the first. So that's an example of what's happening over here, right? All right, so once we have this particular setup, you can create a function that wraps around this particular problem. This problem will pass parameters as a dictionary to a create model type function, where the moment these parameters are given to our class submodule, you immediately get a torch model. So these will be invoked during our optimization process, during our search process, to generate multiple models, right? Okay, so once you have done this, then you essentially use standard neural network training procedures. This is the part that then is exposed to parallelism. So the idea is that you will create a model. The model will then be trained using a certain optimizer, certain choices for our optimization efficiency, such as schedulers, regularizations, number of epochs, so on and so forth. And then the idea is that you could predict some metric of goodness from the model. and you could save the model to the hard disk if you want to recover it later for any sort of post hoc analysis, right? Now, what's important over here is what you return from this model training. Remember, our idea is to search the space of neural architectures um, um, efficiently. So the way this works is that you expose your individual models. So each model you create in this particular function, you expose these to training data, which optimizes the individual neural network parameters for this particular model using training data. And then you evaluate the model on validation data and return the validation data back to a master worker. I will explain that process in a bit. So the idea is training data for finding the right parameters of a neural network, validation data for actually sampling the space of neural network architectures, right? And so the return structure has to be based on a particular format, which essentially the most important thing is the validation data, right? And then some metadata to store during the optimization. Now, one thing to remember is that a neural a network search space, even with options as simple as the ones I was showing you, can generate many complex neural architectures, right? So it's a combinatorial problem. So it is it really this slide really tells you that there's no way you can manually do a brute force search or a random search in this space and get good performance, right? But it's also exciting in that you can actually come up with off-nominal architectures which are quite which may reveal something about your underlying data. So over here, of course, there were skip connections and things which I did not define in this simple problem, but you can also build in skip connections or more complicated architectural design choices into this framework. Of course, it requires a little creativity. Okay, so the way we search the space of neural networks is using parallel Bayesian optimization. You can use sequential Bayesian optimization, and in fact, the tutorial that we have on the DeepHyper GitHub documents is using sequential Bayesian optimization. Oh wait, no, it's using parallel Bayesian optimization using the various cores on your computer. So ignore that statement. You could use sequential if you wanted. There is an option for that. But typically the asynchronous parallel Bayesian optimization is just going to be superior. The idea is that you have a master worker that then talks to so you have a master that talks to various workers to actually coordinate the parallel evaluation of neural network architectures. So for example, each worker would have its own neural network architecture and hyperparameters, and for now, we'll assume they all have access to the same data. If they don't have access to the same data, then the formulation changes a little, and we sort of start venturing into research territory. So I will avoid going there for now, but assume they have access to the same data. If they have access to the same data and they're returning the validation loss, the job of the master is to decide if a particular worker is done with their neural network architecture evaluation and has returned a validation loss, what is the new architecture that should be provided to this worker, right? So the master's job is to actually sample the search space, right? And the way the sampling is done is using classical methods in Bayesian optimization. The first initially when the first set of configurations are evaluated, you can randomly select the search space of architectures, and the master does not have any prior knowledge, so it says, okay, just worker one takes something randomly, worker two takes something randomly, and so on. Fill up the queue. Everybody starts evaluating things, and then as the validation losses are returned, then the master starts building a model for the goodness of a certain hyperparameter configuration. So this is a meta modeling strategy. What that means is that over time there is a surrogate function for that predicts the goodness. In this case, it actually predicts the validation losses of a particular hyperparameter configuration. right? So remember, our individual models were returning the validation losses, but they were returning it after we trained the model. Now the master cannot, master needs to know a good configuration to sample. So it needs to know ahead of time how the validation losses may look like. So it actually trains another model, which is much faster. Typically, this is a tree-based method, such as a random forest or gradient boosted trees, to actually predict the possible validation loss given an unseen hyperparameter. So rather than sending something out and getting the value back, which takes a long time, it says, okay, I need to know if in a particular region of hyperparameter space, I'm going to get a good or bad neural network training. And so here, the use of a tree-based method is motivated by requiring some sort of exploration and exploitation. So the tree-based method predicts a mean value. So this is mu et. So this is not related to the mu that we were talking about in the mathematical background. Here, the mean prediction is telling you, okay, what is the validation loss at a particular hyperparameter configuration theta. The sigma over here is telling us what the variance in the prediction is. So does my surrogate think that there is high uncertainty, model from uncertainty in that particular hyperparameter configuration? And so based on this, our goal is to minimize objective function values or maximize the negative of the validation loss. Then we want to exploit or explore. So exploitation means that we prioritize mu, exploration means we prioritize sigma. The balance between the two of these is controlled by kappa. Kappa is a random variable that is sampled from an exponential distribution by each during the parallel optimization process. So kappa is not set as a scalar value. So there is some randomness also in how you do your exploration exploitation trade-off, right? So you can read more details about this in this paper over here, also read by Roma. Okay, so now that we have this particular setup, and a worker has become free because it's returned its validation loss, then given the current sort of table of returned validation losses, a tree-based method can be rapidly fit. Remember, it's very fast, easy to fit a tree-based method compared to a neural net. And then the master can basically then use the tree to say, okay, for a given theta, my alpha is so much, is coming out to be so much. So it can actually search the space of theta to see where alpha is highest, and then it can use that value of theta to initialize a new sample that is then trained, actually then used to construct a neural network model and train. Okay. So this is kind of the overall architecture or the flowchart of how things work, right? So you're doing a neural architecture and hyperparameter search. You sample from a search space. This search space performs learning using the training data, where it computes a reward using the validation data. The reward is sent back to the search space for another sample, and so on. And of course, this learning and reward computation can be done asynchronously if you have multiple workers availability. Okay. And so, as you might guess at this moment, since this parallel optimization process is parallel Bayesian optimization process lets you sample search spaces independently of other concurrently running trainings. If you have access to large machines, and as you can tell that this slide is also kind of outdated because I believe Theta is retired and Summit and Corey are probably on their way out. So Polaris is still active, but having access to large compute, especially at the DOE, can help you, at least for realistic problems, come up with very good architectures using DeepHyper, right? All right, so I'll briefly go through some quick examples where we deployed DeepHyper. One such example was in a sea surface temperature emulator, where we used the OISST data set from NOAA to essentially just predict the sea surface temperature at a 2-month lead time. The details are in a reference that will show up in a bit. This was an experiment that was run on the retired machine Theta, and it was also run on CPUs. So you can tell it's been a while. And the idea was that we wanted to compare not just, of course, how the search performed in terms of our goal, which was to predict the sea surface temperature, but we also compared various algorithms for the search process. So over here, we have the green line is the random search. So this is what happens if you essentially don't sample the search space intelligently, which keeps which prevents you from really accessing very high performing architectures, even though these are being trained. We can also do other techniques for sampling the search space efficiently. For example, reinforcement learning. So this general schematic of reward being used to sample, you can do this with Bayesian optimization, as I mentioned, but you can also do this with reinforcement learning or evolutionary algorithms, which are different paradigms for basically optimization without gradients. So in this case, there's no gradient of the objective function with respect to the architecture, with respect to the hyperparameter. That's not available to us. And we saw that certain combinations of certain optimization algorithms actually led to improved performance and improved node utilization. So that was something that we recovered as well. The other thing that we saw was there was some scaling law that emerged from this search process, specifically that if you increase the number of nodes that you had access to, these are CPU cores. Well, not CPU cores, these are CPU nodes of Theta. Individually, they had multiple cores, but each node was used to train one neural network. Then we actually observed that you were able to recover more unique architectures that were also having a high performance. So the number of good models was actually, this makes sense because you are able to search for many more architectures, and there's a very large search space given access to higher resources, right? So this is also something that tracks. And when we actually deployed this, the best fit model that we got from this was pre-DIP ensemble. So this is, you can say, the precursor. We just used the best model that we obtained, and we just deployed it. What we saw was, that when we compared it to other sort of classical techniques for time series predictions, so of course this does not have transformers, this does not have even convolutional type methods, because this result is a little outdated at this moment. We were able to get a superior performance, but the title of the slide says, you as the scientist or the user has to determine whether this is worth the cost. Many time series forecasting methods out there nowadays with foundation models, which are pre-trained. You may get similar cost and accuracy without any tuning at all, or with very low overhead. So it's always good to keep up with the literature and see that whether hyperparameter tuning really is kind of worth it in that sense, right? So, but the good thing that we saw over here was, again, compared to like standard libraries and then manual tuning of things like LSTMs, our sea surface temperature predictions were superior. When we compared it against sort of physical benchmarks such as HICOM run by the Navy and CSM, which is of course a climate model, so it's like not really apples to apples. And HICOM is more like a weather type model. We were competitive with the caveat that we had high training costs, but during inference, our model was quite efficient. It could run on a laptop or even a cell phone if you wanted, against those models, which of course require very large resources. So here we're just plotting the prediction of the model. The model was predicting essentially principal components of the sea surface temperature. So it was predicting the entire sea surface temperature projected onto a low-dimensional manifold. So when we reconstructed the prediction from the low-dimensional manifold and we compared the predictions of these various models, we were able to get qualitative agreement at various points. The the predicted metric, the root mean squared error across these models is also competitive. So we were quite pleased with that at least this pre-trained model could be competitive for two-month predictions, with respect to something like HiCom, which of course requires cannot go all the way up to 2 months, and CSM, which is a climate model. So that's the whole subseasonal forecasting range was kind of captured by this approach. So this is something that we were quite happy about. So this was back in 2020, 5 years ago. So this result is definitely outdated, but it serves to be instructional about how hyperparameter search, if you can budget for the high cost, is kind of helpful, right? And so going back to the original point about deep ensembles, now that we have these individual, so in the previous slide, I talked about the prediction from the best possible model, right? Just one model that I trained out of so many in that hyperparameter search. So architecture and hyperparameter search. So now what if we retain a few more than just the best model? Can we get better predictions, but also a quantification of uncertainty, right? So this is kind of the general schematic of how this works, right? So not only are we searching for the best weights, but we search for the best hyperparameters and the best topology, and this increase the search space certainly of our optimization, but also increase the diversity of good architectures and hyperparameters that we can discover, right? And so the idea, going back to our mathematical background and just representing this here in a schematic, is if we know how to build a certain catalog of models given our search. Remember, our search was massive. We were able to, if you have enough compute, look at many different architectures. We cannot use all of them because many of them are quite poor. So we have to find a way to find a good ensemble from all these architectures that we looked at. But assuming we have a way to do that, then we can just essentially do a decomposition into epistemic and aleatory quite straightforwardly, right? The mathematical background, which again was there in the first few slides, I just reiterate this over here for completeness. Is to take the for a given hyperparameter theta, is to find the mean of the variance given a particular input, excuse me, for different hyperparameters, and find the variance of the mean for different hyperparameters, right? So the ensemble, once you construct the ensemble, find the mean of the ensemble with respect to the individual variance, and the variance with respect to the individual means, and this gives you a complete breakdown of aleatoric and epistemic uncertainty, right? Okay, so we actually went and validated the goodness of this particular approach, this law of decomposition of variance, as well as the fact that our search space looked also at hyperparameters and neural architectures rather than just individual models. And we applied this to some traditional sort of CS benchmarks for regression, and we observed that the AGBO over here is a Bayesian optimization technique, which is slightly different from what I introduced to you. But what I introduced to you is what is state of the art in DeepHyper now. But the results carry over. But we were able to get better. So the mean of the ensemble was actually a better predictor than just the best model. Essentially, that's kind of what shows here, because the best model may be biased, right, based on how SGD worked, but the mean of the ensemble was actually better than many other approaches. Standard deep ensembles for sure, Monte Carlo dropout, probabilistic backpropagation, Bayesian neural networks. So this was again, you can read this here in this particular reference. The way to construct this ensemble, there are different ways to do this, but the idea was to essentially ensure that firstly, that individual members of the ensemble were all unique, right? So you don't have repetition for the trained models, and that we would just use a top K type of strategy. There are other strategies as well that we tested in this particular reference, but you can just assume that we're going to talk about the best K models, right? So the best K models, given our validation data, were just appended to this ensemble, and K is a hyperparameter, so you can decide how many values of K to retain. Right. So when we went back and actually tested this on on the same problem, the sea surface temperature problem, we saw something quite nice, where the mean of the ensemble was actually giving us even further reductions in errors for this particular predictive task, which is nice. It validates the fact that our that a hyperparameter search not only gives us a good model, but it also gives us a combination of good models gives us a better performance. But furthermore, we were also able to recover epistemic and aleatory uncertainty as a result of deploying this particular model. So a global decomposition of the same thing. So that is more value from our search, right? So getting close to the end over here, but there's other things that we can actually extract from this search, which is a topic of active development at the moment. I mentioned to you thus far the concept of searching for models given validation loss. So our goal was essentially a single objective optimization, which essentially means that you have to find a way to define goodness using a scalar value. But in many applications, you don't have just a single definition of goodness. For example, let's say you have an application where you certainly want to have low validation losses, but then you also want to have a lightweight optimization, right? So you want to have fewer parameters in your neural network, or you want to have a neural network that has low latency, so the predictions have to come very fast. These are fundamentally at odds with each other in some sense, because neural networks which have lots of parameters are typically more flexible approximators. So how do you take these things off together? Well, at DeepHyper, we have some experimental implementations of multi-objective searches, where we not only where we search for the Pareto optimality in our model. So the idea is that while we are constructing ensembles and sampling, we do like an NSGA, like a non-dominated sorting genetic algorithm search, where our goal is to not find a single best model, but to find an ensemble that corresponds to the Pareto optimal front, right? So the idea is that none of these red models can be dominated by one objective versus the other. So these are optimal in the multi-objective sense, right? So of course you can also do scalarization, which I mentioned over here, which means that how do you if you do have a multi-objective problem, but you don't want to do NSGA or genetic methods for Pareto front extraction, you can also do scalarization, which is an option over here. So so there are options for multi-objective functions, and the other approach that we are investigating now is related to scientific machine learning, which is embedding physics constraints into our models. So the idea is that a lot of research has gone into how neural networks can be trained with physics-based constraints. So for example, in the loss function, not only do you have validation losses, but you also have losses with respect to physics. And so your physics losses typically have gradients. So in that sense, your loss functions will not only be will not only rely on the output of the neural network, they will also rely on Jacobians of the neural network, so the gradients of the neural network. So you would have something, if y is an output, then you'd have a loss defined in y, but you'd also have something related to the first derivative of y with respect to x, the input, right? And so in such cases, you have to differentiate your neural networks, so that requires further function calls of your computational graph. So this is experimental as well, but we are able to essentially also search for good architectures for physics-informed neural networks, or neural networks which have physics-based losses. So, so some interesting stuff that is underway at the moment. Okay, so this is my last slide. I will just leave it here and expect and look forward to your questions. But we are currently working on various sort of downstream both applications and kind of research related to improving things method. One of the things that motivates my group and also our the collaboration as a whole is how we can connect architecture discovery, or so model discovery, to scientific discovery. That's something that's not very transparent in, if you construct an ensemble of architectures, and is there a way we can analyze this ensemble so that it reveals something about our underlying physics or about our underlying data itself beyond just a quantification of uncertainty? This is not straightforward, but this is something that we are thinking about. The second thing is, again, connected to the multi-objective optimization slide. We are interested in incorporating concepts of mixed precision, tracking energy consumption for training of models, and seeing if we can actually construct ensembles, not just with the idea of having a good validation loss, but also with being able to recover improved sustainability characteristics, right? And finally, the third and the fourth point are kind of related. The idea is that we assume that our optimization strategy relied on workers having access to the same data, and also being essentially the same hardware. And in reality, this is typically not possible. Different nodes in your parallel machine may have different hardware characteristics. They may have different amounts of memory that they can leverage. So the amount of data that they may be able to use for training can also vary. In such cases, a worker that is trained on a fraction of the data should have its validation loss be treated differently as against a worker that looked at all the data. So these are some things that add some uncertainty, a different sort of uncertainty over here, that we need to factor into our search process. So this is something that we're thinking about at the moment as well. So I will stop over there. I want to thank everyone again for their attention, and thank you to the organizers for this invitation. I'm happy to take questions now, but I'm also happy to chat after, and I look forward to your thoughts.
Thank you so much, Romit. There seems to be one question in.
Should I stop sharing my scheme? That way, maybe.
Yes.
Yeah.
Feel free to stop sharing. Okay. So Daniel Abdi asked, can the tool be used to quantify uncertainty in diffusion models in which noise is added explicitly in the initial input and during each denoising step?
So I'd have to think about that a bit. So if you think about diffusion models, it doesn't really fit the general mathematical framework I set up, because that is a generative model, right? So it's learning a distribution. In our case, so you can certainly quantify the model form uncertainty, right? So if you think about a diffusion model which has weights, you can train multiple diffusion models in parallel, and you can generate samples from each diffusion model. assuming each diffusion model is generating samples that correspond to the data uncertainty, then ensembles or diffusion models will correspond to the model form uncertainty for the diffusion model. So I have to think more about this, but my initial answer would be yes, it can be. Yes, if you interpret that the denoising process is going to capture aleatoric uncertainty, then multiple diffusion models trained in parallel can capture the model form uncertainty.
Romit, I think we might have lost your voice for your audio for just maybe 10 seconds, 20
Okay,
seconds.
can you hear me now?
If you can repeat the last sentence that you mentioned.
I said it can be possible, yes. So the diffusion model individually can be assumed to be dealing with the data-related uncertainty, and then multiple diffusion models ensemble can deal with the model form uncertainty.
Sounds great. Are there any questions in the audience in person? If yes, please feel free to come up to the microphone. Seems like Brian has a question.
Yeah, I'll ask a question. At the risk of asking you to give a whole nother talk, I'm a little curious. Like, can you speak a little bit more on your thoughts on how you want to incorporate energy awareness into this process, and how you optimize for energy efficient AI?
We haven't done that yet. We would like to do that in the future. So one of the things that we did look at, which is a poor proxy for energy efficiency, is something like the number of parameters in the model. So we assume that if the number of parameters are lower, that's typically a step in the right direction when it comes to energy. The other thing we looked at was the latency. So the inference costs, for example, for predicting on a fixed validation data set, if a certain model is taking a long time, that was also a step in the same direction, right? So that's kind of how we looked at it. But like I said, since the Bayesian optimization formulation calls this black box function evaluation, right, for an objective function query, you could have profiling tools in there, right? You don't have to differentiate through that. So the profiling tool could tell you exactly how much energy was consumed, and that could be something that then goes into the optimization logic. So, but we haven't done this yet.
All right, thank you. Yeah, totally understand it's future work. Just I know that's an area of interest here at NCAR, so appreciate it.
Yeah, happy to chat. Yes. Yeah.
Thank you, Romit. There's another question in the Slido. Have you tried RayTune library in your work? I'm not sure if the RayTune has got some development that can help you in tuning. I wanted to also ask, how does this compare to Optuna and RayTune? So yeah, if you can explain how this compares to other hyperparameter optimization frameworks such as RayTune and Optuna, that would be great.
Yeah, so we did compare against RayTune in the sense of node utilization and efficiency on Argonne machines. And we saw that, I mean, in some sense, it's not a fair comparison because we were Argonne scientists on Argonne machines comparing against RayTune, and we landed on our own sort of communication protocols, which were superior. So I know there are many different hyperparameter libraries out there, and each individually has its own benefits and sort of negatives. In this particular case, I think since this is kind of a DOE driven project, it has a bit more ownership, a bit more users, and easy to kind of deploy, and it's a little easier to deploy on DOA machines. So that is, I think, where we have a slight advantage on those other libraries. I'm sure it would be the other case if you talked about something like the cloud or AWS, where maybe those would be superior because we haven't really done anything over there. So in practice, the concept I introduced today with deep ensembles I'm pretty sure you can set it up with other hyperparameter optimization libraries as well. It's just that ours is ready to go on these large LCF type machines.
Thank you, Romit. So if I recall correctly, DOE machines, they use Slurm. And I was wondering if it supports other schedulers like PBS Pro, or maybe, I don't know if all DOE machines use Slurm or not. But what schedulers does this support?
So this is agnostic to the scheduler, right? So this has run with various, I mean, Theta was PBS, but then now it's running on Polaris, which is Slurm, if I'm not wrong. You can, on my campus cluster, it's PBS. So it's all called through Python, really. So maybe I can quickly share my screen and just show you the or maybe I will not, but if you go to the DeepHyper website, there are actually let me share my screen. Why not? If you can see my screen, so there are ways to install this using on your local machine, but they also have one moment, the documentation changed. They also have examples for setting this up on ALCF. So let's see, maybe it's in the. I'll have to look for it, but there are let me search for it. Yeah, maybe the documentation has to be updated, but there are examples where you can set this up on ALCF and NERSC and so on and so forth. So I would so that's it's independent to the scheduler, basically is kind of what I'm saying.
Sounds good. Yeah, I'll follow up offline about supporting it potentially on, or trying it, testing it potentially on NCAR supercomputers.
Sure.
I have another question. So I was wondering if I understood correctly, the number of workers, they are training different, technically different, like machine learning algorithms, or like with different weights. And
Yes.
so would it be possible to have distributed training? So if you want to have like 4 workers training one single neural network, and then 4 other workers training another neural network, and then another one neural, like GPU or node or worker training on neural networks, kind of like that.
Yes, it's
that
possible.
Okay.
It's possible. I don't think we have a tutorial for that, because that becomes very machine specific, because there's all these environment variables that you have to set, but it is possible. Yes, we have done that.
That sounds great. That sounds perfect. Are there any other questions in the audience or online? I don't see any questions in the Slido. Oh. Actually, Amit asked, are there specific instructions to use on PVC?
I am not familiar with what PVC is. I'm really sorry about that.
What was it?
What is PVC? I'm sorry.
Intel GPUs.
Specific? No. There is all of these these results and slides I showed you. These were either on the really old ones were on Knight's Landing, so Intel CPUs, but the recent ones are all NVIDIA. So I do not know the situation with the latest Intel GPUs. I know at Aurora they have started using the Intel GPUs, but I have not personally done that myself. So I cannot answer this question. I'm sorry. As you can tell with my ignorance about PVC. Yeah. So.
Well, sounds great. Thank you so much, Romit. Let's
Sure.
thank our speaker once again.
Thanks. And yes, feel free to reach out to me or Roma he's really excellent, and he's very interested in incorporating our suggestions and things as well. So yeah.
Well, thank you so much, Romit. Okay, so we will convene back again here at 10:20. So yeah, thank you, everyone. And I think we will have refreshment outside in the hall area. So thanks.
Okay. Oh, we'll be getting started in just a couple minutes. We'll be getting started in just one more minute. Okay, good morning, everybody. We're going to get started. We have our first talk coming up on Manica, software and space science, developing open source metadata management.
Hi, thank you guys so much for letting me be here. I'm really excited to give this talk to you guys, and also massive thank you to the organizers of this conference for the student registration support. It's like super appreciated. So yeah, let's just jump right in. This is software in space science, developing open source metadata management. I'll give a quick little introduction. I'm Anna. I'm currently an undergraduate. I have a dual degree in computer science and astrophysics at the University of Colorado Boulder. And I'm here with my association to LASP, which is the Laboratory for Atmospheric and Space Physics, and the IMAP mission. The IMAP mission is the Interstellar Mapping and Acceleration Probe. If you were here yesterday, you would have heard one of my mentors give a talk about the software architecture, which is pretty cool. But I'm here to talk about how we handle metadata for CDF files. So let's get into, be very nice to me. Okay, let's talk about space science and why metadata is important and how scientists can go from data to conclusions. This is a really cool graph that I made for a research course in the APS department, which is the astrophysics department, that is graphing the solar wind velocity by this, like the radii out, which is using the Parker Solar Probe. It's a super cool graph, but how do scientists use the information gathered on spacecraft and by instrumentation to actually create graphs like that? There's a lot of data there. There's a lot of metadata there. Who knows how any of that works? I certainly didn't until this job, where I learned about CDF files, which are very, very complex file formats. CDF stands for the Common Data Format. It holds scalar and multidimensional data, and it holds metadata for variables. And because there is so much data, that stuff is really, really complicated. Let's move on. So we have the problem aboard the IMAP mission of having lots and lots of data that we need to collect and lots of metadata that we need to categorize and also put alongside that data. So doing that is a pretty complicated software task. And so we come to the IMAP first attempt of collecting metadata for this mission and then linking that to CDF files. The first attempt was to have all of the developers write their own methods for collecting metadata into the actual instrumentation code. So every instrument had their own methods to collect metadata and set the metadata, and we would communicate with the scientists and say, hey, what are we trying to collect? What units is it in? Why is it important? And then we would hard code that into the processing algorithm, which means that there was no uniformity. There were multiple functions that completed the same task, so the code base was honestly just getting really, really full and really messy. And a lot of developers were working on different instruments. And so you would have to completely change your mindset when you were going from CODIS, which is like one of the instruments, to GLOWS, which is a different one of the instruments, that have different methods and different ways of handling this metadata, which was no fun. So we come to the actual solution, which is now being used, which was to create a couple of different files with the code that handles the metadata. We have the CDF attribute management file, the IMAP CDF management, and then SAMI, which is a really cool thing. I'll get into that a little bit more here soon. The CDF attribute management file is a dynamic file that handles metadata for developers in general. So anyone who is using metadata for CDF files, they can go in and they can use all of the code in that. And it's going to be applied to missions across all of time, or honestly, just people who are using CDF files and need to categorize metadata. The IMAP CDF management is a file that holds IMAP-specific metadata. For the mission, we have some variables like a global file that has metadata for the whole mission that we really need to keep track of. So that's for us specifically. And SAMI is an open source repository that's going to be used by the NASA Hermes mission and the IMAP mission that uses the CDF attribute management file, and we put it into the IMAP repository. So SAMI is really what matters to you guys, because the IMAP stuff doesn't necessarily apply to you all, but if you're wanting to use metadata management for CDF files in general, you can go look at this really cool repository. I'll have a little QR code for it if you're interested. Taken straight from the GitHub, SAMI, the Shared Attribute Metadata and Management Interface. It's a Python package that provides a schema for metadata attributes within space weather data products. This package is an SW-SRC project that can be used in conjunction with other SW-SRC projects or as a standalone package. So this is what you guys really want to think about. And I want to walk you through how this works and how you can use it in your work if you have metadata that you want to make a little bit easier. The two files that we have are the IMAP CDF manager and the CDF attribute manager. There's a couple of different functions, one that handles global attributes and one that handles variable attributes. And the IMAP CDF manager is what really calls to all of the functions in the CDF attribute manager, which you can find in the SAMI repository. I'll walk you through just a quick little use case example for our instrument GLOWS, which is it's the L1 processing file. And there's so much information that we need to take care of. When we are conversing with scientists about the different data products that we're creating and about the different information that we're taking in, there's lots of thoughts that they have about what it should be called, what units it's in, how that should be conveyed, because the ultimate point of the metadata of a CDF file is so a scientist can just pull that file up, say, okay, I have a kilometer, a variable in kilometers, and I want to take that and I want to graph it and I want to make it look nice. So we need to store that somewhere. And so we've created .yaml files, which hold all of that information, which is really easy for a scientist to go in and say, okay, this variable is in kilometers, this variable is in seconds, and this is the time frame that we want to use it for. And there's no issue between the developer who is creating metadata management and the scientist that wants to put all of that information there. So we have to then link the two together. And to do that, the first step is to create an attribute object. The attribute object is defined in the CDF metadata management file. And you can see we have a little use case example there. We got the GLOWS attribute, which is creating that variable. And we load in the different files. So we load in the instrument GLOWS, we load in the metadata for level L1A that we need to develop processing code for. And then we add some global attributes like the data version, and we just create that as an object that we can call to. In the actual processing code, you can see that we link back to that object with just a variable. Super easy, glows attributes, create glows attribute object. From there, we're going to actually work into generating the CDF files from the processing algorithm code. So we have just, it's a super simple thing. The generate histogram data set, that's a function that's created later. That's actually using the processing code for the glows instrument. We link all of the attributes to it. We do that in a couple of different places. We return the data sets. You can see here in the little bottom picture right there, that's where we're actually calling to the metadata that is stored with the objects, and it's just put into a data array object, and it's held very nicely and cleanly. Let's get into the development across time. I've been super lucky to step into this at a really interesting position as a student developer. So when I first started coming to LASP and working on this project, I just started off with writing the unit test cases for the CDF attribute manager file, which was a great way to actually step into that code. If you're someone who doesn't have a ton of experience and you're walking into a massive code base that you don't know tons about, that's a great way to get your hands on the code without messing anything up too seriously, which is what I needed. So I just started writing some unit test cases, make sure everything was held well, displayed well, we weren't losing anything in the process, which allowed me to then move on to creating some methods in the global attribute manager. I started working on variable attributes, so it's just a lot of methods on taking information from these .yaml files that we communicated with the scientists to create and hold it in the objects that we needed. From there, I got the chance to actually talk with some really cool people that are working on the instrumentations. I particularly worked on the GLOWS instrumentation and the IDEX instrumentation, and talking with the scientists about what they needed, how they needed it, what was useful to be displayed, and then putting that in the .yaml files, which would then be actually linked to the CDFs that we were creating. After that happened, the repository SAMI was created, which is what you guys will all need. SAMI is awesome. You should 100% go and check it out. I'm super grateful that some of the code is in there. Handling CDFs is awful, and if you've ever had to do that, I am so sorry, and this will make your life so much easier. The best part of this entire process for me has been the opportunity to actually work on something that's open source. I grew up in a family with a bunch of developers, and we all hail open source technology and open source code. And it was really cool to feel like I was contributing to that. And so I really hope that you all, if you have to deal with metadata, want to use this open source product. It's really great. I decided to end on a quote from our dear Linus. I often compare open source to science. It's what we're all doing here. Science took this whole notion of developing ideas in the open and improving on other people's ideas. It made science what it is today, and it made the incredible advances that we have had possible. And I compare that to witchcraft and alchemy, which openness was something you didn't do. So I hope you all really appreciate SAMI. I hope you all want to use SAMI. You should. It's made my life so much easier as I've gotten a chance to get into the processing algorithm code. And I hope that that helps you in your work as much as it has helped me. Thank you. I can now take questions. These are QR codes to each repository, the SAMI repository and the IMAP repository. Both are open source. Please feel free to contribute and be part of a really cool thing.
Are there any questions? I have one. I'm curious, are there any domain-specific conventions in play, like the CF conventions for climate forecast?
I know that for IMAP specifically, we have a lot of conventions in our code base. In terms of the SAMI repository, I'm not actually sure. Maybe my mentor could answer that. There are domain conventions. There are. This is actually the creator of the SAMI repository, and she's one of my mentors at LASP. So this is Maxine.
We follow the heliophysics standard for CDF files, which is called ISTP.
Thank you very much. Any other questions? And we're running a couple minutes fast. So I will go ahead and introduce our next speaker. Our next talk is Jiachen Lo with implementation of Hyperdual-Step method in CMAQ for numerically exact sensitivity analysis. Thank you.
Yeah, thank you for the introduction. My name is Jiachen. I usually go by Ed, and I would like to thank Professor Capps and also the ISS conference committee for the registration support. So let's dive right in. Just to give you a brief introduction of and motivation of our study. So sensitivity analysis, which involves calculating derivatives of model outputs with respect to inputs, is critical in many scientific software applications. So these derivatives reveal how changes in specific input variables influence outputs, providing essential insights for model evaluation, optimization, and also uncertainty quantification. The traditional way of doing these kind of sensitivity analysis is to use finite difference methods, but sometimes they suffer from cancellation and truncation errors, especially when we're interested in estimating higher order derivatives. In 2011, Fike and Alonso developed hyperdual numbers for calculation of exact first and second order sensitivity as second order derivatives to machine precision. And we have implemented the method in the community multi-scale error quality model, CMAQ, to compute exact sensitivities. And let me just give you a brief introduction of sensitivity analysis in general. So let me dive right into the physical meaning of the first and second order sensitivities in models. So first order sensitivities are easier to understand. They reflect the slope of the relationship, how the output changes in response to a small change in input. So here on the right panel, we have a hypothetical data of PM2.5 concentration on the y-axis, and either NOx and SO2 emissions on the x-axis. So the top panel basically demonstrates a positive first order sensitivity as f of x, which is the blue curve, is moving up with an increasing NOx emission. The first order derivative are also positive, but in this case, because it is concaving down, the second order derivative is negative. In the bottom panel, we have both positive first order sensitivity with a positive curvature, which is concaving up. So these kind of analysis is quite important in chemical transport models like CMAQ, because many of the atmospheric processes are strongly nonlinear, especially the aerosol processes and atmospheric chemistry processes, making both the first order and second order sensitivities crucial for analyzing these system responses. So that was a brief introduction of why sensitivities matter or derivatives matter. So let me give you a super brief introduction of hyperdual numbers, which is a pretty complicated word for most of the audience. So I will just give the basic operation rules of hyperdual numbers here. A hyperdual number is written as x of h equal to x plus x1 epsilon 1 plus x2 epsilon 2 plus x1 2 epsilon 1 epsilon 2. So the arithmetic operations following specific rules that preserve the structure of the hyperdual terms, which means that the epsilon 1, epsilon 2, and epsilon 1, epsilon 2 terms won't disappear. And the key characteristic is that the square of epsilon 1 and epsilon 2 are equal to 0. And the epsilon 1 and epsilon 2 terms so captures the first order derivatives, and the epsilon 1, epsilon 2, x1, epsilon 1 multiplied by epsilon 2 term captures the second order derivatives. So calculations with hyperdual numbers are generally intuitive, although the definition is somewhat a little bit hard to understand. Following rules similar to those used with complex or imaginary numbers. So remember, like complex and imaginary numbers have I, which I squared equal to -1, but in this case, it's just the epsilon squares are equal to 0, but they themselves are not equal to 0. And details about the derivation and all the calculation rules can be found in Fike and Alonso's paper, published in 2011. So how do we use hyperdual numbers to calculate sensitivities is another question. So traditionally, with finite difference, we basically run the model multiple times to estimate the first order and second order sensitivities. In this case, suppose we have a super simple model that if you give the input of NOx emissions, it gives you output of PM2.5. To get the first order sensitivity, you need to run it 2 times, and you do basically a simple first order approximation to get the first order sensitivity. The Hyperdual-Step method is actually quite similar to this. Instead of stepping in the real dimension as in the finite difference method, you step in the hyperdual dimension by adding a specific hyperdual number to the input of interest. And if your model is compatible with hyperdual numbers, you will be able to get, in addition to the real output of, say, in this case, PM2.5 concentration, you'll be able to get the first order sensitivity and the second order sensitivity through a single model run with the Hyperdual-Step method. Yeah. So in order to achieve this, we have developed this hyperdual operator overloading library in Fortran. So we developed this which includes over 400 operations for hyperdual numbers. And these operations are tested offline for their accuracy in both the real number space and also sensitivity calculations before being applied to the model of interest. And a key advantage of the hyperdual number approach is compatibility with models that involve complex numbers, enabling broader application across scientific software. So to give you a quick summary, up until this point, we have developed this hyperdual number operator overloading library, and this is the addition operator, for example. And for CMAQ, it's basically just a model that contains physical chemical processes and also atmospheric transport. You take in emissions of, say, SO2, NOx, volatile chemical products, you will be able to get concentrations of pollutants. And through some source code modifications, we get CMAQ-HYD, which can let users calculate the sensitivity of output concentrations with respect to emissions, both in the first order space and in the second order space. So let's dive right into how we have implemented the method in CMAQ. And to compute exact sensitivities, I will just give a brief example of some of the results that we have. So this is more of a proof of concept run of CMAQ-HYD. We have the model configurations is from 7 p.m. EST on January 1st, 2019, to 7 a.m. EST on January 2nd, 2019. The domain is the 12 US1 grid, which is shown on the right. And we are using CV6R3, AE7 chemical mechanism, and also the Arrow 7 module. So what is shown on the right is a CMAQ versus CMAQ-HYD, and they're the real PM2.5 concentration after a run. So the main takeaway here is that the mod, changing it from the regular CMAQ to CMAQ-HYD doesn't change the real output. It just gives you additional information about the sensitivity. So let me show you some of the results of this run. So what we have here is the partial derivative of PM2.5 concentration with respect to a semi-normalized emission of volatile chemical product, or NOx. So here shown, let's look at the right-hand side first, which is the first order sensitivity of PM2.5 with respect to NOx. A positive first order sensitivity basically means that an increase in NOx emissions will lead to an increase in PM2.5 concentrations. What is quite interesting is that volatile chemical products, which also sometimes is seen as a contributor to PM2.5 concentrations, and in parts of central US, is actually there's a negative relationship, which means that an increase in VCP emissions will actually lead to decrease in PM2.5 concentrations. So one explanation is that in parts of the central US, VCPs actually react with nitrate to form a monoterpene nitrate product, leading to less ammonium nitrate formation, which leads to actually a negative sensitivity. So this is what CMAQ-HYD can provide you with a single model run. And in addition to the first order sensitivity, which is the top two figures that was actually in the previous slide, we can also get the second order sensitivity in this case, which describes the curvature of the relationship. And so it is mostly linear for the relationship between PM2.5 and VCP, which is the bottom left panel. But the PM2.5 relationship with NOx is actually much more nonlinear. Essentially, if we look at this and go back to one of the previous slides that I've shown, it's actually at this white star point on this plot right here, we have a positive first order sensitivity. and a negative second order sensitivity. So essentially, we're at a specific point of NOx emissions, and we have basically a response curve of PM2.5 and between PM2.5 and NOx, and we are at this specific point. So our model can provide this kind of information to users through a single model run. Lastly, in addition to the second order sensitivity, we can also perturb. We can also try to understand the cross sensitivity of, in this case, NOx and VCP emissions. I have the first order sensitivity on the left-hand panel still, and on the right-hand side, we have the cross sensitivity. As you can see, there are some positive values. So the positive cross sensitivities here means that reducing anthropogenic NOx will actually lead to a decrease in first order sensitivity of PM2.5 with respect to VCP. So the two independent variables in this case, NOx emissions and VCP emissions, have a synergistic impact on the PM2.5 concentration. And if the cross sensitivity is negative, which it means that reducing NOx will actually lead to an increase in first order sensitivity. So the two dependent variables are acting counteractively. So basically what we have shown you is an implementation of the Hyperdual-Step method in a complex chemical transport models. But like most of the audience here are interested in the software. What we actually want to convey to you is that it doesn't have to be CMAQ. It can be your model. And through some source code modifications, you can get the sensitivity of outputs with respect to input of interest. And let me just give you a brief introduction of what the source code modifications are. So I'll just give this example using the vertical diffusion module in CMAQ. So the only actual change of source code is changing the real variables of interest to hyperdual. So in the right-hand side, you can see that this is the subroutine VDIF. And previously, the C-grade variable, which contains the concentration, was real numbers. So the only thing you need to do is to use the use HT-mod, which uses the hyperdual number operator overloading module, and convert your variable type from real to type hyperdual. If the models are computationally expensive, we can selectively change the variables of interest to reduce the computational overhead of the model. And a typical CMAQ HYD run in regional scale is 2.5 times as expensive as the original model. So not too bad, because to get sensitivities through finite difference, you basically need to run the model 2 times for first order. And for higher order, you need to run it at least 3 times. So this is more like a manual source modifications. You have to go into each of the file and modify the variables. We can, if the model is not computationally expensive, we can use this hyperdualized.py and help modify your code to be compatible with the hyperdual number module. So we have developed this file called hyperdualized.py. It can perform automatic source code modifications because the idea behind this is quite simple. You just convert the variable types. And after converting your model to your model-HYD, you compile both your model-HYD with HT-mod. You can get sensitivity information out of it. And here is a QR code. Don't worry about it. I will show it at the end of my presentation. It contains both HT-mod and hyperdualized.py. Lastly, I have developed this flowchart for hyperdual number-based sensitivity analysis. So the only real decision you need to make is to determine whether your model is computationally expensive. If it is computationally expensive and you really care about the performance of your model, a manual conversion, which might give you better performances because you don't need to convert all of your variables to model.HYD. If your model is super small, and you can basically run hyperdualized.py to generate your model-HYD, which will be a little bit more computationally expensive, but it's much simpler than manually converting all of your code. After getting your model-HYD, you compile your model-HYD with the hyperdual number operator overloading library, and you can run different sensitivity analysis using additive or multiplicative hyperdual number perturbations. In conclusion, we developed the HTML-F90 and the hyperdualized.py to enable first and second order derivative calculations in general Fortran-based models. We demonstrated the effectiveness of Hyperdual-Step method in 2 chemical transport models. And tune in for my colleague Samuel's work at 3:40 today for more discussion about the implementation in GeoSchem. And we are working on developing tools that help users to interpret the sensitivity analysis results. And the ongoing work focuses on refining and expanding the automatic conversion framework. And here's the QR code. Let me give you some of my acknowledgement. We would like to acknowledge the funding to Professor Shannon Capps, the NSF career funding, and also registration support, high performance computing from NCAR, and some of the emission data from people working at EPA, and also debugging from a forum, EPA-sponsored forum called CMAQ. And here are some of the references. I'll leave this QR code here, and I'm happy to take any questions. Thank you.
Thank you very much, Ed. Are there any questions from the audience? While we wait for people to formulate questions, I have one. Forgive the naive question since I'm not a domain scientist. Can you talk a little bit about the how you compared the outputs from the CMAQ DDM versus the work you've done and what you observed outside of the easier maintainability of CMAQ Hyde?
Yes, sure. So CMAQ DDM is a similar way of computing sensitivities, and CMAQ HY our benchmark comparisons have been against a finite difference of CMAQ runs, but CMAQ DDM the development of CMAQ HYD is a little bit more, the initial development is quite complex. But one major advantage of CMAQ HYD over DDM is that when there's a model update, you don't necessarily need to rewrite new equations, which CMAQ DDM, sometimes you have to, especially in the cloud module. In CMAQ HYD, you can just convert the variable types and apply the, if the variable types are converted to type hyperdual, you automatically do all the sensitivity calculations. So that's the major difference between CMAQ DDM versus CMAQ HYD. In terms of, so that's basically the major difference. I hope that answers your question. We for all the benchmark runs, we are comparing CMAQ HYD versus a finite difference approach. Yeah.
Great, thank you. Any other questions? Oh, we have one.
Yeah, great talk. I was just curious. Clearly, it cleans up the code, and I can imagine being, computationally faster. But have you looked at what the impact of memory is? Because it seems like you're obviously now, instead of holding one floating point number, you're holding 3 floating point numbers per each number. So yeah, I guess, what did that look like in your work?
Yeah, I would say memory overhead is definitely a problem, or a disadvantage of the Hyperdual-Step method, because essentially, you are holding 3 additional floating point numbers. In CMAQ, that's more of a problem because CMAQ is more like a pseudo parallel approach, and it takes all the information back to the processor 0, rank 0 processor. But if you're able to use some of the there are pure parallel based approach like PNet CDF approaches in CMAQ that can help alleviate the the total sometimes CMAQ HYD will have memory overflow because it transfers all the information back to the processor 0. But if you're able to leverage some of the PNet CDF approaches, that can help you with the memory overhead. But definitely memory overhead is there, and it is definitely a disadvantage of this method.
Great, thank you.
Yeah.
Thank you. We have another question.
Yeah, thanks for the talk. Just had a quick question about your hyperdualize script, and you talked about, a future direction is trying to add improvements in that automatic conversion process. I always find these scripts kind of interesting because, it's hard to guess the intent of what the end user really wants for the output. So do you have any thoughts on directions you'd like to take that script?
Yeah, so I would say Fortran is pretty flexible in terms of how you can define variables. Like you can declare it, you can do real and real 4 and real 8 and real, maybe your customized kind equals to something. So that was one of the major difficulties of developing. So the conversion itself is quite simple. You just convert all the variables to type hyperdual, and that's it. But the main challenge here is to find the proper places to convert them. And so that was the whole point of hyperdualize. But in terms of so it could be better, I would say. Like this is a new development. So because previously we have done a lot of manual conversions because for CMAQ, you don't want to convert everything and it will be super computationally expensive. So we are trying to make it better at this point. Yeah, it was.
Yeah, it's a tough thing to get right, but appreciate it.
Thank you.
Okay, thank you, Ed. Great presentation. Next up, we will be hearing from Prentice Bisbal. The first step to making your code more accessible, make it easier to build and install.
Okay, good.
Okay, good morning, everyone. Looking at the title, I kind of have to wonder why I said make your code more accessible. I mean, it is relevant to this, but I was thinking about when I was going to title this, and I could have come up with a million different names for this talk. I'm coming at this from the point of view of a system admin who's been responsible for building and installing scientific software for literally decades now. And basically, my big pet peeve is that it's much harder to install than regular software. And I'm hoping I can convince you to spend some time and think about how to make it easier for your users to install their software. And I'm going to hopefully show you some suggestions on how to get there. So a little bit about me first. Originally, I started out as an engineer, so I like to bring it up because I feel like I'm coming at using HPC more from a scientist or engineer user point of view than a purely sysadmin, IT perspective. I've been working in HPC for over 25 years, and during that time, installing user software has been a very big priority part of my roles. Actually, until I came here on July 1st, that was always a big part of my job, and now that seems that's Brian's job for the most part, taking care of the user space software. And I've probably gone through the build process, thousands of times and probably built hundreds of different packages. And building like a lot of the scientific stuff has really been the bane of my existence. Now, again, this is my first, this is basically my argument for today. The premise for my talk is that, the first obstacle to get a user to use your software is to have them be able to install it. And if they can't get past this stage, they're not going to use your software. And in general, now notice in general is emphasized there, because there are exceptions to this, scientific software is much more difficult to compile and install than more general purpose software. Now I'm talking about general purpose software. I'm like Bash, maybe Apache, a lot of stuff that comes from the maybe Free Software Foundation. That's kind of like the core of like the Linux open source computing environment. Now, if you can make your software process, the build and install process easier, it can lead to it can help improve the success of your project. And here's why. If you can make your software easier to install, it's more likely to be installed. If it's installed, it's more likely to be used. It's more like, if it's more likely to be used, it means it's probably more likely to be cited, which means it's better odds of getting, continued sustained funding or even increasing your funding. And, more funding means more resources, which can go to improving a software, and it just becomes a positive feedback loop, a virtuous cycle. I don't know about every single granting agency, but I do know that a lot of times if you're being, paid to produce software for public use, they're going to want to see how many people are downloading that software, if it's having an impact on the community, and all these things, having the software be easier to install, making it more available to the users, can all help that. And then, of course, if you are a researcher that's part of the publish or perish world, the more people cite your project, your research, your software, the better that is for you and your scientific career also. So this is a tale from experience, and where I really realized the importance of making software easy to install, as well as teaching computational scientists how to build this stuff. I used to work at the Institute for Advanced Study in Princeton, and every year they had this summer program called the Prospects in Theoretical Physics. In 2009, when I worked there, the topic was computational astrophysics. And so they wanted to teach the students not just how to do computational astrophysics, like the theory and using the applications, but how to be a fully functioning computational scientist, which meant being able to install the software themselves, being able to use it on their laptops. So when they're sitting on a plane, they could be doing work, stuff like that. And I had set up a cluster, a 48 node cluster. It was an older cluster we repurposed and installed all the software there so they could run parallel jobs. But all the instructors were like, that's great that you did that, but we also want them to be able to download all the software themselves, compile, install it, and run it on their laptop, because we think that's an important part of being a computational scientist. They'd set up a mailing list for the students to talk about problems themselves and help each other with their homework. And they added me to that list in case there was any technical issues with, like, submitting jobs and running them on the cluster. Well, guess what? Almost for the 2-week program, almost every single email on that mailing list wasn't about the science, wasn't about how to run the program. It was, why can't I get this to compile and install on my machine? And there was about 200 students, I think it was about 200, like maybe 178, something like that. I'm not 100% sure. But that was 8 hours a day for almost 2 weeks, was me answering questions and giving guidance on how to, run a configure script with the right settings. If it fails, if the configure script fails at a certain point, what that problem is. And I like to give more than just the basic answer. Like, I like to teach people to fish, not give them a fish. So I'd often say, okay, if you can't find a file that ends in .h, that's a header file, which means that you don't have your preprocessor flag set up right. So you need to do this. If it errors here, that means that it's a linker flag. These are all things that, these guys had to learn, and it's part of the build process. But if you have a good configure script or configuration process, it should be able to find a lot of those things on their own. And so you're probably like, well, what is the difference between my experiences building general purpose software and like scientific applications? Well, for the more general purpose stuff, they typically have a configuration script that determines, what dependencies are available on the system, what are the proper compiler flags for that processor, and the linker flags to make sure it links all the right libraries. For me, as someone who's never been the expertise in the domain of the science that I was supporting, having a make check is a big deal. For the general purpose stuff, it'll run a bunch of checks, and it will let you know whether it passed or failed the test, and overall if the software failed. And then there's a make install, which will install the different files in the correct location. It will put the library files in a library directory. It will put the executables in a bin directory. It will put man pages and documentation in a directory named share. If there's config files, it'll put those in Etsy, stuff like that. And this may seem like a trivial thing, but I see this lacking a lot in scientific software and just poorly written software in general. Easy to determine the version before and after installation. When I download a tarball from the website, I want it to have the version number in that tarball so that I know what version it is in case I got to go back later and install different versions. A lot of people like to distribute software from like GitHub or something like that. And when they make a tarball, if it's not tagged, it will just say like main or master, and it won't even have the software version name. That's a little detail that can mean a lot to the people that are responsible for maintaining your software in your environment. Now, for scientific software, okay, these aren't all necessarily from one application. These are just different things I've experienced over the years supporting software. Users, the configuration process is edit our example makefile, or the makefile at the top level, figure out what needs to be changed for your environment, and go from there. As a sysadmin, I kind of could do that. Well, as a computational scientist who's focused on their science and not focused on computing, that is a very tall order, especially when you get into parallel applications where they might need to link to like MPI libraries and other libraries that are relevant to getting it to work in parallel, right? I don't think many users are going to be able to determine the correct compiler flags on their own for different optimizations, like whether to use AVX 2, AVX 512, stuff like that. I've seen ones where the binaries are just compiled right into the source directory, and they expect you to run the binaries right from there, which is not good. Very bad housekeeping. Other times they do have a make install process command, but it puts everything in the same file, regardless of what type of file it is. So they have binaries next to library files. They might have config files or input files all put there. Not good. Also, files installed with unsafe permissions. As a sysadmin who is responsible for trying to keep security under control, that makes my head explode. Again, no easy way to determine if the software is working as directed. Sometimes, I've seen software that has a build process, a check process, and it spits out results, but as somebody who doesn't know the software and isn't a domain expert, I can't tell if those are valid results or not. So having something that just says pass or fail just is like, goes so far if, the people managing your software are not domain experts themselves. And again, no way to determine the version of the software before or after installation. Now, and after, it's nice if you can run a command with like a -v or -- version and see what version you have. That is a big deal to the people that maintain your software, because if there's a bug in it, if there's a fix, oftentimes we get users that say, oh, we need this version because it has this new feature we need for our research. And then, I got to look and be like, well, what version is on there now? And they'd be like, well, I don't know. And I'm like, well, how am I supposed to know if I wasn't the guy who installed it, right? Because sometimes you have a team of people that manage the software. So this is just a simple example. I chose FFTW because it is kind of a sciencey package, and it is very quick and simple to install. It doesn't have a lot of dependencies, but you can't see that here. But I just wanted to show you some things that, it's a simple package. If I just run, when you untar it in the top level, there's a configure script, which you've heard me mention like a million times by now. You just run that configure script. It will probe the system, determine all the correct settings. You run make. You can run a make check. It'll do like a sanity test and give you pass fail results. And then you just do a make install, and we'll put it in all the right places. Now, if you want to have more control over it, you can just use different flags to specify different behavior you want it to do. Like, for example, if I want to install multiple versions of FFTW or not have it conflict with the version that was installed by the operating system, I want to install it in a different prefix. So I want to install in user local FFTW-3.3.10. That way I know what version is installed in that location, and it's also in a place where it's not going to conflict with the system provided version, because FFTW is a scientific package that is often included with Linux distributions. -- disable silent rules. That's just a rule for me. It makes it more verbose when it's compiling and doing the configure stuff. So it's easier for me to see possible issues. Not really necessary, but I like to have it. Enable shared. That allows you to build shared libraries if they're not the default. I always like to explicitly define enable shared and enable static, because I never know what my users are going to need. So that covers all my bases, right? Enable long double, tells you what precision you want for the library. If you're on Intel, and I think even the newest AMDs now support AVX 512, you want to specifically enable it to get the most performance out of your processor. Ideally, the configure script will detect the proper processor itself, well, you might want to be explicit about that. Enable MPI, obviously just enables MPI, but the point is, all of these are things that you can easily specify without editing make files and knowing what compiler flags or the long incantations you need to make that happen in a make file. And then finally at the bottom, CC and MPI CC, those are environment variables that say, I want to use GCC and I want to use, the lowercase MPI CC for the parallel compilation. Those are good to set if you have multiple compilers. And again, if you were to do this in a make file, you'd have to edit the make file and see if or where those variables are defined and then change them there. It's much easier to just do this very quickly on the command line, and it lends itself to very quickly scripting this. And then the rest, like you saw in the previous simple case. So what does configure do? For those of you that aren't familiar, it runs a bunch of little tests and it can identify the processor, what compiler you're using, the location of dependencies and their versions. And then it takes that information and determines a suitable, optimization flags for the processor, other compiler flags you might need, like whether to build for shared or static libraries, the precision, whether you want to support OpenMP or not, and then finally the linker flags. And then it can also, and then it will set these variables in a make file so that, they get propagated through the whole build process. Now, I've been mentioning configure a lot. The configure script is something that the developer has to build for their script. And there's a GNU package called GNU AutoConf, which helps them build that script. I'm not a developer, so I don't know how it works from a developer point of view. I just know it from a consumer point of view. But it's very common. It's by far the most popular tool for this, but is not the only one. The next most popular is probably CMAQ, which is from Kitware, and Kitware is a commercial company, but CMAQ is a free open source product. My previous employer, we had an agreement with CMAQ, so I think there was kind of a push to use CMAQ for this on all their software that where I worked put out. There's another tool called SCons, which you don't see that much anymore, but say 20 years ago, I used to see it a lot more. And I think there's a few other options out there, but you really don't see them that much. They're almost like one-offs, but there are other things out there. And my goal here isn't to sell you on GNU AutoConf. It's just really to say that there are tools you can use to make the build process easier for your users. So some people say, allowing our users to build the tools themselves is kind of a pain in the butt. It's better if we just build it themselves. We build the binaries ourselves. That way we don't got to worry about having a flexible build process. Well, there's problems with that. Can't be optimized without limiting portability, right? If you optimize it with AVX 512, then it can't run on any processor that doesn't support AVX 512, which is like almost every AMD processor except possibly their latest versions. Number of processor, the number of processor types and accelerators is increasing, right? You don't just have NVIDIA GPUs, you have Intel and AMD now. You don't just have, for a long time, AMD and Intel were identical, but there is a little bit of divergence at the in the details that can make a difference in performance. So if you compile something that's, works on Intel very well, it may give lousy performance on AMD or vice versa. And now we have ARM processors, which I think are going to become very big in HPC in the next few years, between the NVIDIA Hopper processor and Apple, switching to ARM is going to make it a much more popular processor, which means now you're going to have to build a lot of different binaries. And then there's also multiple MPI implementations that your binary is going to have to work with. And then you have the lower level libraries like UCX and PMI. These are all things you got to worry about, which really for performance-oriented HPC, you can't really, doesn't make it practical for the developers to maintain binaries for all the possible combinations that users might want to run on their clusters. Containers. People say, oh, it's just better to distribute it via containers. And this drives me nuts, but this is where a lot of developers are going right now. Oh, we'll just make a container. They can download the container and run it. Does not fix all the problems. First, you got the same issue as precompiled binaries, right? You got to optimize it for the different systems. Now it adds an additional layer of complexity for the users whether they're launching the jobs. Now they got add additional layers to launch the container. For debugging it, it becomes harder. And for me as an admin, that also makes it harder for me too, because I got to deal with those layers when I'm supporting users. And then which container system to use. I know that they're all largely similar and they all support Docker files, but that's still something that, can be an issue. And then of course, in HPC, we want to minimize overhead as much as possible. And they say there is not a lot of overhead with containers, but I'm sure there is still some non-trivial amount that could make a difference, especially as you scale to bigger and bigger, number of cores that may add up and have a non-trivial amount of negative impact on your performance. And what about third-party distributions, right? Why don't we just wait for Red Hat to package it as an RPM or have somebody issue it as a deb, or why don't we just contribute it to SPAC and let it be distributed through SPAC? Well,
1 minute.
Thank you. All of these, you still need to worry about, the same things I said already. And these will probably mean that the version often lags far behind the latest version. And like Red Hat and Debian and Ubuntu, they really don't care about scientific software because it's a very niche market for them. And it's not something that there's a priority for them to do. Maybe something like FFTW that's used by many different packages, MPI, yes, but like the actual end applications is not really something they're going to worry about. So what should you do? Good artist copy, great artist steal. Put a question mark after Picasso because people always attribute that to him. But from what I've read, there's no proof he ever said that. And this actual sentiment goes back much further than him. Find a project that, is easy to build and just look at it. See how they're doing it, see what they use, find the documentation for that. There's the GNU Hello project, which doesn't specifically, I think, use AutoConf, but it does illustrate GNU coding standards and maintainer practices, which are used in a lot of projects. Might be a good way to learn some best practices. I'll go through this real quick. Funding agencies, criticism of this is that people say funding agencies don't pay us to make software usable. They pay us to do science. I don't always agree with that. Oftentimes you have a responsibility to make your software available to the rest of the community, and making code that's available, but they can't build it doesn't mean it's really available to them. And I also think this is something that needs to be baked into your whole process. People act like I'm telling them to go back and say, okay, now that I wrote your software, give us another grant to go back and make it usable. That should all be baked in from the beginning, in my opinion. Conclusion, we're out of time, so we'll skip that. I think I'm just repeating myself here. And questions?
Thank you very much.
Any questions, complaints, criticisms? I've had other people yell at me for some of these thoughts, so you won't be the first.
Not a question. I 100% agree with you on the containers and on your assessment on builds. In SPAC, I'll talk about this on Thursday. We built environments of 400 something packages for, supporting all the atmospheric models that then combined with JEDI data assimilation. And so 95% of these packages built all the time, and maintaining them in SPAC is easy. It's the 5% of scientific packages that eat up almost all the maintenance time that we have for keeping these packages to build, because they have all these customizations built in there. So yes, go for a good build system, make it use standard variables, make it installable following best industry practices. If you have not started and looking into any of these build options, I would recommend going to CMAQ. People usually have some sort of history, and so if somebody's attached to Make, that's fine. But if you have no preference whatsoever, CMAQ is a great place to start with. It makes your life so much easier. So thank you.
Thank you.
Thank you.
So yeah, with CMAQ, what I find when I talk to developers, like it seems like new AutoConf is better for end users like me, but for the developers, CMAQ seems to make it easier for them. Like that's what I've heard, that it's easier from a developer to set up stuff with CMAQ. But I don't know. Like I said, I'm not a developer, so.
I have maybe more of a comment, but just a question also. Have you tried the Fortran package manager at all? And if not, I'd recommend adding it to your list. It builds Fortran projects, it builds C projects, some C++. it's probably more oriented towards small projects or people who are developing their own code as opposed to system administrators who need to install something for a multi-user system. But it is, I used CMAQ for a dozen or so years. I used Make for a dozen or so years before that. Nothing has even come even remotely close to being as simple as FPM. Just this morning, I built Super LU. So I'm more of a Fortran developer, but Super LU is a sparse direct linear system solver. It's about 60,000 lines of code. I had never looked at the source code, had never touched Super LU before. I put together a 10-line file for FPM, 8 lines of which was just boilerplate. 2 lines of which were telling it where to find the include files, and it built all 61,000 lines of files or lines of code there in Super LU. So easily the most easy to use build system I've ever touched.
Okay, thanks. I'll take a look at it. Thanks for mentioning it.
Super LU is in C, I guess I forgot to mention that.
Yep.
Thank you. One quick question. Maybe I'll ask you offline. We have a minute
Sure.
left. From a sysadmin standpoint, one of the strengths of CMAQ, and please accept my apologies as the NetCDF lead dev for difficulties with packages. CMAQ will let you install dependencies automatically as part of that. How does that affect you as a sysadmin with that kind of being taken behind the curtain and happening without?
If it can handle dependencies on its own, that's great, because there's this term called dependency hell, which a lot of sysadmins talk about. And to give you an example of how bad that can be, somebody wanted me to install a new version of like ImageMagick or something like that, or it might have been GIMP. And because of all the different image manipulation libraries it depended on, it took me an entire month to build all the different dependencies just to get to that point where I could build it. So that's like full time for 4 weeks. That was all I worked on because of all the different dependencies. And if it can manage dependencies properly, that is great, which is one of the benefits of SPAC. The problem I have with SPAC is that I've had some difficulties getting everything to build exactly the way I want it. And I think even the SPAC developers know that, and it's still a work in progress, but it's a huge benefit for people in my place, or actually Brian's now, over building every single thing manually. And the biggest problem with dependencies is sometimes they want to document that, okay, I need this dependency, but it doesn't say exactly how it needs to be configured. Like it may need to support shared libraries, but it doesn't build it by default. So you get like to the final step when you're at the final boss, and now you got to go back because a couple of your dependencies weren't built with the right configure options. And that is, a hair pulling experience,
Great. Well, thank you very much.
Thank you, everybody.
Moving on to our next talk, David Pettifor with designing a spectrum visualization platform with flexibility in mind.
Hey, good morning. And my name is David Pettifor. I am a research software engineer manager, and I also serve as a technical lead on my team.
My name is Melissa Harden. I'm a senior product owner on our team. So I help determine the what of what we're building while the technical team determines the how we get there. And sometimes we describe this division with the product owner and the software developers as I help make sure that we build the right thing, and they help make sure that we build the thing right.
We both work within the research software engineering division at the Center for Research Computing. So the CRC has 2 teams composed of a manager, product owners, and research software engineers, about 20 people in total. And this is at University of Notre Dame, which you can see on the slide. So our center's mission is to facilitate multidisciplinary discoveries through advanced computation, research software engineering, artificial intelligence, and other digital research tools. Today, we are presenting on the visualization platform that our team is building for one of our projects. This platform is for radio frequency spectrum data and is part of Spectrum X's flagship Project 1.
I'll provide a little bit of context here about Spectrum X. So this is not weather related or atmospheric science related, but Spectrum X is an NSF-funded center composed of scientists, engineers, and educators from multiple institutions. They provide policy and technical contributions through research and educational activities. The center's home and lead PI is at Notre Dame, which is how we came to be involved with this work. One of the center-wide projects that they're currently working on is called Flagship Project 1, which is focused on spectrum awareness and analysis for coexistence. So radio frequency spectrum coexistence. It can be summarized as enabling next generation sensing, awareness, and understanding at scope. There's a specific focus on the 7 to 8 gigahertz range with an aim to demonstrate the possible for coexistence. It has 4 main areas, as you can see here, and our team is working on 2 work elements. There are multiple work elements in each of these 4 areas. Our team is working on 2 work elements within the data infrastructure and interfaces area. So we're working on a spectrum data system, and we're also building a spectrum visualization interface. So just to kind of give you a little bit of a map of where we are, today we're talking about specifically that visualization interface.
So our visualization platform is designed to facilitate exploration and analysis of radio frequency data, catering to a broad audience that includes experienced researchers, novice analysts, and even policymakers. To achieve our goal of this kind of flexibility, we have focused on creating a user-centric interface that allows for multiple methods of data access, including private uploads and integration with publicly available data sets that are stored within our data system, and also on the visualization interface. And so both of these, in the blue and the green, those are both being developed within the CRC. So we're building the SVI, or the Spectrum X visualization interface, for 3 types of main users. So researchers, which include faculty members, technicians, which are operators, though often, they're ones that are often running the experiments, but not always doing the analysis, and policymakers. So each user group has potentially different skill sets and skill levels that and needs when interacting with the SVI. So we have to design it with flexibility and to be used by this wide range of users. So because the interface is being designed to allow for radio frequency exploration and analysis for users coming from different backgrounds and with all different skill levels, one primary feature that we're developing is a visualization wizard, which you can see here. This allows users to walk through step by step the visualization creation process. They only need to know which data sets they'd like to visualize and which type of visualization that they want to create. The wizard will then let them make additional configurations if needed, but that depends obviously on which visualization they select. So while this feature is inspired by other data visualization platforms, including one previously developed at our center, we have had to make other decisions specific to this platform and sets of users. So this is a screenshot of what the visualization wizard for a waterfall currently looks like. We're still working on finalizing this UI, so it'll continue to be updated as we iterate through the design and get feedback from end users about what they actually want to see here. So kind of take a stab in the dark. How does this look? And get feedback. So as the technical lead and manager, I've had to think about a few things and make some decisions. So one thing that we've been thinking a lot about is client-side versus server-side computation and calculation. So we opted more for server-side and to allow for a wider range of users to use the system and to bring a unified experience regardless of end user equipment. So it doesn't matter if you're on a desktop, a PC, or even mobile, you can have access to all these visualizations. This also enables us to be in control of the need, so the ability to purchase hardware clusters and dedicated servers or GPUs if we find we need to cross that barrier. Another question or decision that we've had to make is how to manage moving large sets of data for visualization. So for those that are familiar with wireless spectrum data, it generates a lot of data. And so balancing data aggregation on the back end to support interactive widgets without overburdening the client or their connection, because not all of us have fiber internet connections. Another technical consideration that we've had to make is how do we link it up to our data system. So we provide documentation on APIs that are exposed on our data system. Plus, we have a long-term support Python library package that we're developing that is published under PyPy. We've also had to determine the best stack for what kinds of visualizations we know what we want to support. So like I said, I mentioned the waterfall. There's other visualizations that we're planning, including spectrograms, heat maps, interactive heat maps, and time series plots. So we went with React for the front end and a Django REST framework for the back end to help support this. And part of that decision is also trying to figure out where can we reuse code from other existing projects. So the waterfall visualization, we actually borrowed from another project that was being developed at Notre Dame. This mean and because we were building this waterfall using existing code, we had to build a solid relationship with the software engineer that was in that department. So we've been working very closely with them.
So while David focuses on these technical considerations that he just mentioned, I engage with our end users from a slightly different perspective. I'm just sort of curious if anybody in the room has worked on a team with a product owner before. Okay, a few. Yeah, so I don't have a software engineering background at all, but we actually kind of see that as a feature, not a bug in many situations. And so I kind of come at this from a little bit different. We attend often many of the same meetings, but I'm listening in to hear from our researchers, particularly in the RF and wireless communication space, which I'm also not a subject matter expert in. And I'm just listening to their questions, to their comments, to their discussions in these meetings. And what I'm trying to pull out from that are like bits and pieces about their values, how they work, what matters to them when it comes to actually conducting their research, but also like how tech savvy are they? How willing are they to pick up new processes and new technologies? And that helps inform how we go about building our products as well. It also helps me identify the features. I'm the sort of the one who decides, or in conjunction, in collaboration with our team, but ultimately prioritizing the work, the order in which we're going to develop our features. So I have to think about priorities, timeline, milestones, deadlines, all of those things too. So just for example, based on discussions, questions, and other contributions at meetings, we have learned that the wizard that we are creating will provide benefit to many users based on what we know about their skill levels. But we also know that there are certain researchers that want to be able to make very specific customizations to like a waterfall or a spectrogram or to a heat map or whatever it might be. So we could then go build, 100 different wizards for every particular type of visualization that we hear come up, or we could think about allowing our interface to have a separate section where they can actually go in and make their own specific customizations to that, which we'll talk about here in just a minute. So that allows for the flexibility for us to build something that works for them for right now and for any potential future case that we don't yet know about. I also ask questions when appropriate to better understand overarching project goals and steps. This can be really hard for me. Like I said, I'm not an engineer and I'm not a wireless communication expert. And sometimes I kind of say things like, this may be a dumb question, but have we thought about X, Y, or Z? And I can't tell you the number of times that they'll say, oh, that's a good question, or we haven't thought about this before, which then helps us raise issues that we know that we need to document or put in a parking lot. Like we need to come back and we need to talk about those things and make some more decisions, at least in the next few weeks or months, depending on project timeline. So that can be really helpful too. Because we're working on just 2 work elements within a much larger project, as I mentioned at the beginning, there are many moving pieces and timelines and targets. So I also listen in to hear how other work elements are making progress. Recently, we found out we were reliant on data to come in from a different work element, and they are a little bit behind schedule. And we could sit there and wait, but we ultimately made a decision to pivot and build this interface, actually working with a different data format while we wait for the other data format to come in. So we will have to turn back and regroup once we actually get the data that we're kind of waiting on. But this allowed us to keep making some forward progress, building a framework out that we can hopefully kind of plug into when we're ready with the original data source. Yeah.
So as mentioned before, we have a strong desire to allow for customization for visualization and analysis. So we've decided to do this by integrating a Jupyter Hub instance, which, based on previous talks, I think most of this group is pretty familiar with. The goal here is to give users the flexibility to make calculations, adjustments, or specific configurations to their data to customize and meet their needs, rather than confine them to the predefined visualization that we've made. Because we're aiming to reach a user audience of varying needs and skills, we recognize that predefined visualization widgets may not go far enough for some, especially researchers in this field. So we've had to make decisions about like which Python packages we pre-install. So here you can see one example of spectrogram, and that required a number of Python packages to be able to produce that. So we've added things like NumPy and Matplotlib, SciPy, Pandas, and then our own in-house SpectrumX library that allows us to connect to our data system. There's still a few things that we need to consider, things like user space quotas, because Jupyter Hub allows you to upload your own files, and I don't necessarily want somebody uploading several terabytes of their data to our Jupyter Hub instance, unless we can support it. But also user accounts right now, it's kind of open-ended. We're using a third-party authentication service. So if you've got a GitHub or a Google account, you're kind of in. So
1 minute.
We need to watch that.
So I'll just wrap up here. We do work within an agile framework, which it can be really interesting, can be really, really helpful. This does sort of put us in an interesting position, right? Because the idea here is to present work in an in-progress state and get feedback sort of fail fast or pivot when needed, rather than waiting until the entire thing is built and then find out that it's not what they were looking for. I find that to be a particularly vulnerable situation to sit in, to present work that I know is not done, and to say, like, we get that this may not be exactly what you were thinking, but I want to hear your feedback so far. We take that in, and then of course we use that to inform our next priorities and next steps. We do have to then have this mentality of flexibility. And even though I know all of this, at some level, it still feels like, okay, this is normal to get this feedback and we need to keep going. And usually it's actually very positive and productive feedback, but it can sometimes feel kind of odd or a little on the spot. We have had the opportunity to demo our visualization platform to researchers multiple times over the last few months, and we have gotten really great feedback along the way. And so this is just, as an aside, like a really great, has been a really great opportunity for us to keep moving forward and keep progressing without waiting for too long for there to be actual feedback to come in. Overall, I think that building this visualization platform has been an interesting experience, trying to keep focused on main user groups and needs while also taking in sort of like niche requests and customizations. It does at times mean that we have to focus on one specific use case to get a feature completed before moving on to another one. And then there's that communication. This is just again, as an aside, a benefit of a product owner is that I can handle a lot of those conversations so that our research software engineers can focus on developing and building code, and they don't have to get kind of mired in the details and timelines and lots of meetings unless it's like really appropriate for them to be there. But I try to provide that buffer and to take in the feedback, synthesize it, and provide it back and go the other way as well. Yeah.
All right. Are there any questions?
I just loved your talk, and I loved the dual presentation there. That was awesome. And a big challenge in scientific software is the partnership between scientists and software engineers, and it's difficult to get that right. So what you presented here is there's really a partnership of respect for each other and listening to each other, and that sort of thing. Is this how new is this project? Was it kind of built this way from the ground up, and have you done it in other projects, or?
You mean the product owner relationship or like the actual spectrum visualization?
I guess this specific one, is this like your first time of doing like an agile kind of framework, or? Okay,
well,
yeah, cool.
Sure.
I'll let you take this.
Yeah, so our center actually moved to Agile 8 years ago, something like that. So we've been practicing this for a while.
Okay, cool.
It does work really well on small projects. And I guess it also works really well in big projects. This is kind of one of our big, yeah. This is kind of a bigger project. The project itself, we only started getting involved last July-ish. But within our center, I think we're the only ones that are using the agile method, specifically with product owner and developers.
Right.
Yes,
Yeah. So, but the way that our center is set up, we work with researchers from across campus from all areas. So I have worked on projects, software engineering projects from, psychology, computer science, history, now engineering, right? So we take in projects from all over and we just work within this method kind of however we can kind of make it fit to the project, to the size, to the scope, to the length.
Okay.
Yeah.
And you always work as the product owner?
Yep, that is my role.
And you kind of liaison with scientists in the different departments?
Yes, and at various times, and I've worked at the CRC for 3 years. There have been periods of time where I've had 5 to 7 projects in my portfolio, and they're all tiny. And now this one is huge.
Right.
And so this is really my main focus, and I kind of work on one, but it's 2 work elements and multiple research software engineers. So it varies. The way it gets applied changes depending on the nature of the project.
And your background is in a science?
So that my
field?
background, interestingly, is in libraries. I have a master's in library science, and I was a product owner with our libraries IT team.
I see.
And so I worked at the library at Notre Dame prior to this, which is how I got experience as a product owner. I moved over to the CRC, but what I'm finding is that library and information science is widely applicable in many different situations and contexts. So yes.
Okay.
Yeah.
Cool. I'll contact you later.
Sure,
and ask more.
absolutely.
Thank you.
So we have time for one more question.
Great. Thank you both. Really great talk, David and Melissa. So can you comment, first of all, I really appreciated your description of product owner. Can you talk about how it might be different from a project manager, or maybe where there's overlap between those 2 roles?
I can definitely do that because I last year worked on a project where I was actually more of the project manager role. I'm not a certified project manager or trained really in that. So there is, in my mind, a Venn diagram. There are tasks that overlap a little bit, but there are areas where a project manager, I think their tasks sort of differ. And again, I think that this might be very context dependent. When I worked at the library, I worked on a project where I was the product owner, but we had a project manager. And so kind of navigating whose responsibilities were what was, I think, a little bit of a challenge there. I think more in terms, a product owner is thinking more in terms of like actual product development, feature development. And I think of a project manager thinking a little bit more in terms of like, managing budget, timeline, goal, like deadlines, RACI charts. They have all these tools that are so useful that I try to apply as a product owner when we don't have a project manager on our team. I'm not sure that I'm doing it right. So I'll just like disclaimer, I don't know. Maybe I'm totally doing a disservice here to what a project manager can bring. They are amazingly powerful on teams. I think I just sort of sit back more. I ask a lot more questions about like, what would you want it to look like? How would you expect this to function? When the thing is built, how do you want it in a perfect scenario? How do you want this to work and look and feel? And then I sort of work towards that. Not that a project manager can't do that though. So I think it kind of maybe depends.
Yeah, that's great. I think the idea of the product owner could be really useful in a lot of tools that we work on. So thanks for describing.
Yes, sure. Yeah.
Thank you. We're going to move along to the next talk, but thank you very much. That was great. So our final talk of this session, Tori Marbois, my apologies if I've mispronounced that. Modernizing legacy systems, updating the MAVEN Science Data Center for improved performance and maintainability.
Unfortunately, these are not my slides. Mine's the one with the picture of Mars on it. It's black.
Just give me a minute to pull your slides.
Anybody got any good jokes? Okay, I'll tell you my favorite one since you're dying to know. It's actually a math joke. What did the acorn say when it grew up? Geometry, yes. I love that joke.
We should open with questions. What are you going to talk about?
You're not even gonna let me just give the presentation? Okay. I mean, I can introduce myself. Yeah, my name is Tori Marbois. My pronouns are she, her. Hey, Mars, great. I know that I am what stands between you and lunch, so I will try to be succinct and entertaining. I work at LASP, the Laboratory for Atmospheric and Space Physics. It's on CU Boulder's East Research Campus, so it's 3 minutes down the road. I'm a data systems engineer. One of the missions I work on is MAVEN, which is a spacecraft orbiting Mars. Next slide, I'll tell you what MAVEN stands for and what the mission is about. But today I'm going to be talking about modernizing the legacy system of MAVEN, updating the Science Data Center for improved performance and maintainability. I'm going to be talking about what we've done to improve our system, what is currently happening to improve our system, and what will be done to improve our legacy system on MAVEN. So MAVEN stands for Mars Atmosphere and Volatile Evolution. It's a spacecraft that's been orbiting the planet for over a decade now. It explores the planet's upper atmosphere, ionosphere, and interactions with the sun and solar wind. Our current members on the Science Data Center and the SDC is myself and my colleague Brian. Past members who were involved in these improvement efforts I'm going to be telling you about are Veronica Martinez and Sean Hoyt. Here on the Science Data Center, our responsibilities include receiving and being stewards of data that's created by over 10 instrument teams for the spacecraft mission. We maintain a website that hosts documentation on our data products, access to the data itself, and plots and different tools and things that allow people to model the data and use it for their own science. And in addition to this, we also deliver quarterly releases to NASA archives of our data. The reason we started improving our system, what kind of kickstarted that, was about a year or two ago when Veronica and Sean were onboarded. It was the first time that anyone new had been onboarded onto our team in over 8 years. So my teammates realized that our documentation was out of date. There were some obsolete design decisions that had been built up over the years that were now causing confusion. Deploying the code was tricky, and even getting to the point where a developer could simply run our unit tests was pretty difficult and unreliable. So it was important that something changed. A little bit more about our website, just to give you a scope of our work. This is a screenshot of our kind of 90s, 2000s looking website. And that little drop down red menu is just a list of some of the instruments that are part of the mission. That's that plot that's on the lower half of the screen is a track of the page views over the last year of our website. It was about 1,200 unique views, which averages to 200 a week. So it's not like Facebook, but it's like not a little. There are people out there who are using our products and our data. So now to get into some of our completed improvement efforts, we upgraded our running Python version to 3.9. That's what we write our code in. So all the Fortran talk is like way over my head here, but and we also updated our operating system, which is Red Hat to Red Hat 9. We replaced our testing database from a Postgres database to a serverless SQLite database. And then a lot of things having to do with moving to open source. Our backend code repo was a private GitHub repository. We moved it to be a public open source repository. This also included moving our project within GitHub that includes all of our tickets and tasks and tracking of things that we get done, moving that to a publicly available board. I want to mention here that while moving a private repo to a public repo in GitHub is fairly straightforward, there's a lot of documentation out there about how to do that. Moving a project board with tickets and tasks from private to public is actually impossible to do in bulk. You have to manually recreate tickets in your public repo. So we had to, my colleague Brian had to just manually create and copy over every single ticket we have. So if you're thinking about moving from a private GitHub repo to a public repo, you should do that now before you create like 20 new tickets in a new project. In addition to this, in GitHub, we created a Codespaces configuration. Codespaces is kind of like a containerized, small scope way to develop your code in a repo. It's a really cool feature that GitHub offers. And so we use that to test any website changes before we deploy them to our production environment. Lastly, we've done a lot of revamping of internal documentation. LASP uses Confluence for our internal documents. And I'm especially grateful for this effort because I was onboarded onto the team about 6 months ago. And I can't imagine how long it would have taken me to come up to speed and be able to start contributing to the project if my teammates had not already revamped our documentation to be really easy to follow in terms of the processes we run and how to contribute and the different nuances of our system. An in-progress effort that I'm working on right now is moving our internal storage archive, which is just essentially, I mean, it is what it is, which is an archive of all of our files, all of our data files and configuration and things like that, which is currently hosted on a deprecated AWS vault. The concept of a vault is no longer a supported service by AWS, and the script that archives our files to this Glacier vault was written over 12 years ago. So we've moved our archive to an S3 bucket within AWS using this tool on that right-hand screenshot called S5CMD. It's a wrapper for the AWS sync command, and it's able to run things in parallel and make this syncing process faster. To give you a scope of everything, our archive is about 63 terabytes of data with 10 million objects. So this was not a little effort, and I would have loved if I just could click a button and it went up really fast, but it took a little bit of time. That left-hand screenshot is just a picture of our bucket. Future efforts we would like to take on is containerizing our backend code with Docker. A couple years ago, we containerized our website code with Docker, and it's paired really nicely with that Codespaces GitHub feature that I mentioned. It allows us to tear down and push back up our website very quickly so that no one experiences downtime when they're trying to access our code and access our data. And so we'd like to be able to do that with our backend code. It's just a little bit of a beefier project to take on because it's, a backend code, so there's a lot to it. In addition to that, we would love to automate some notifications. The way that our system works, and I forgot to mention that our servers that we work with that host our data are on-prem. The way that this works is that our instrument teams who create the data after it comes down in the binary stream from the spacecraft, they push the data onto a Dropbox server, and we have a bot that runs and grabs that and then puts it onto the on-prem server. And there's not a lot of visibility there into when that happens and if it fails and if it's successful. And so we'd like to create a notification system. This is just a screenshot of some random integration tool with Slack. Slack is our communication tool at LASP. And it would be great to have an integration bot that posts to either an existing channel for the mission or a new channel that's specifically for notifications. At a previous role, we had a lot of Slack integrations like this, and they're really helpful for visibility into ongoing systems and when things fail and et cetera, et cetera. So here's the good stuff. Here's some lessons learned. The first one is that change is incremental. I think we all know that, but maybe we lose sight of that when we get really excited about something. We're like, I'm going to improve this thing, and oh my God, it's going to make my team's life so much better, and I'm going to get it done in 2 weeks. And then reality hits you, and you're like, this is going to take like 4 months. And that could be a bit of a bummer, especially in the space mission workspace. We have small teams. It's just me and one other person. And so change takes time. And while this can be frustrating, it's actually a really good thing to help you minimize risk. My sense from having talked with teammates and other people in this industry and people who work with legacy systems is that there's a lot of hesitancy in improving systems because you don't want to have some interruption in service. You don't want to take down a server and then all these scientists are like banging on your door like, where's my data? So you don't want to risk that, which makes a lot of sense. It's our job. We want to support people and what they need. And as we've been talking about at this conference, improvements are important in maintainability and ease of access for ourselves, our future teammates, and the community at large. And you can minimize risk with a phased approach, which goes hand in hand with this idea that change is slow. So for example, when my teammates updated our Red Hat version, they kept our old server with the older Red Hat version running, kept all of our connections and things and processes pointed at that old server until they had tested the new one enough to make sure that it was going to run as they needed it to. And then they turned off the old one and pointed everything at the new one, and it was fairly seamless. So that's just an example that you don't have to like out the gate, like just leave yourself hanging with nothing and you're like, hope it works. Like it's okay to give yourself a net and to take things slowly. Oops. Sorry, I got excited. Okay, so next I want to talk about leveraging community tools, especially about moving to open source. There's so much out there right now about using GitHub to be open source and moving different things there. In my opinion, in my teammates' opinion, it's kind of a one-stop shop for having a modernized open source system. You can put your code there, obviously. You can use GitHub Actions to run workflows. You can use code spaces to test your developments. You can have your project board there with all your tickets and tasks. So there's a lot out there about how to move your existing system to GitHub. And it's important to lean on that rather than, I don't know, trying to figure it out yourself. I don't know. I don't think any of us would do that. We're all smart people, right? So just reminding you that resources exist. And also there are resources where you might not expect them in your local groups. Let's say, for example, at your next lunch and learn in your department, you decide to give a talk about this thing you're thinking about doing to improve your system. And someone approaches you afterwards to say, hey, I did that last year. Here's what I wish I knew. Here are some tools that you can use to speed up the process. So I would recommend, talking to your colleagues, talking to people in our community about what you're trying to do, and hopefully you'll find different ways that you could do things better and learn from our teammates here in this space. Last thing here is that documentation is not to be overlooked. First point here is about unit tests. We've talked about testing here, and I just want to say that like when I first became a software engineer and someone was like, you got to write unit tests first, I was like, no, this is so boring and I already wrote the code and why am I testing that 1 = 1? I was so annoyed. But now I look back and I feel really grateful for that teaching, because now when I write code and I've written a comprehensive test suite, I feel so much better about it. And I know that when I come back and I have to make changes to my code, I know that it's going to continue to run and produce what I need it to. And that future colleagues are going to come into my code and be like, I know exactly how to run this. Hopefully, 80% of the time, hopefully that's how it is. And so we set ourselves up for success, and we set our teammates and our future colleagues up for success when we write comprehensive testing suites. In addition to that, writing down what you do and how you problem solve is also incredibly helpful. For myself, I have developed this habit of I have a running Word document that I just keep open. And every day I write down the little things I do. Sometimes I'm better at writing things down than other days. Often I use this as a place as like a kind of a receipt. And I paste errors in there and I say, here's this thing I'm running and here's why I can't get it to work. And here are the different things I tried to solve it. And eventually when I find the solution, I write that down too. I end up usually posting like article links and specific like Linux commands, and here's how I solve this issue. And it makes my life a lot easier when in the future I inevitably run into the same bugs again. And it means that eventually when I sit down and I'm like, all right, I should write a document in Confluence about this new process we're running, I have something to go off of. I'm not just trying to write it from scratch. I think that my hunch is that I'm not alone in that being a software engineer means I don't like writing things. So writing a new document from scratch can be really intimidating. So I would say help yourself out by writing down things about these processes you're creating or this class you're writing and this module you're developing. Write it down somewhere so that you can come back and easily compile it into a document for yourself and your team. That's it for me. You can find our public GitHub repo at MAVEN SDC. You can contact my team at that second email, and you can contact me personally at that third email. Thank you.
Thank you very much. We have time for a few questions. I'll start with one, a quick question. How did you handle prioritizing the push to do new work while also modernizing the existing infrastructure?
That's a really good question. thankfully, since this mission has been running successfully for over a decade, there aren't a lot of new products that people need. Like it's a pretty well set running system. And so I think my team was able to prioritize little like biting off little pieces of this modernization effort while supporting our ongoing responsibilities like that quarterly archive release, like I mentioned. And I think that's probably going to be different for every team. And it's a matter of what's like pressing, and do you have someone like knocking on your door every day like, hey, is this thing done? It's like you want to make your life easier and you want to support the people that you're meant to support. So I think that's kind of a roundabout answer. Sorry.
No, thank you. Good question.
I was really interested, you talked about GitHub code spaces, which I'm not familiar with. And so can you give a description of what they do?
Yeah, so I'm not the one who set up our code space configuration, so I'm afraid that I'm not going to be able to give the best explanation of what it is. I would really, I mean, if it were me, I'd be like, let me just go Google GitHub code spaces right now.
Yeah.
So I would recommend you look into it, but specifically, it works well with containerization and Docker, and essentially GitHub deploys an image, like a local hosted image on GitHub of your code. Like for example, with our website, I can just go to like this like off like URL that's like the GitHub like container name and then my website URL, and I can look at the changes specifically with like HTML. That's really helpful because HTML is kind of finicky. But I imagine it can be used for other reasons. That's just how our team is using code spaces.
Okay, cool. Thank you.
Thanks for your question.
Any other questions? Great. Thank you very much.
Thank you.
Too soon, but still thank you.
It's okay. You can clap more. It's fine.
Yeah, sorry about that. I
Okay.
was actually thinking about moving your code base to GitHub public. How did you manage, or don't you have proprietary APIs and stuff? How did you manage them?
You said proprietary APIs?
Yes.
Like private kind of credential secure stuff?
Yeah.
So our APIs have always been meant to face the public and to be used for public access of the data. So API specifically, I don't think there's a lot of lifting to do there, but that reminds me, something I wanted to mention was that we had a lot of private credentials in our private repo, things that were like security tokens and things like that. And so when my team made our backend repo public, they had to comb through really carefully and make sure that there weren't any private credentials left over. And the way that they made it so that they could keep the code pretty much as written without these hard-coded security credentials was they made environment variables on our servers that can get plugged into the cron jobs that stand up and run these processes that are built on these scripts. So now the cron job just looks and finds the local environment variable that have the private credentials but can still run the script, and the script is public. Does that answer your question?
Yeah. And the last question. So in the process of going open source, did you have to go through the hurdles of maybe administrative and business, how do I put it now, decisions?
No, because it's a longer mission. It's a little bit more lower stakes. It was pretty much just a team-led decision. And within NASA, there's a new initiative, like a recent last couple years initiative called TOPS, which is the Transition to Open Science. And NASA itself is supporting and encouraging people existing in new missions to move to open source with their code and their data. So it's kind of like an industry-wide push to make things open source. I meant to also, I'm so grateful for your question because I meant to mention these things. If you Google NASA Open Science 101, NASA offers a free course with all these different notes about how to make things more publicly accessible, to move to GitHub and different open source tools. So if you're thinking about making any part of your system open source, I would really recommend Googling NASA Open Science 101. And I think it could be really applicable and helpful to just have a nice, neatly packaged list of resources to do that. Thank you.
Okay, thank you very much. And with that, we're going to break for lunch. We will reconvene at 1 o'clock I've been asked to announce that there may be limited seating compared to yesterday because of the parallel meeting going next door. But welcome to eat in here or find seating outside if that is to your liking. But thank you very much. Enjoy your lunch.
Oh, fun. Yeah. Not bad. Oh, yeah. Wow. Yeah. They like oh, yeah. Going out, they're like, yeah. 5 minutes. Yeah. Oh, yeah. I remember our first time. That was like, I think that was. Did you have the color? Yeah. No, I think that was too far. That was like out of it. That was like our computer. Yeah, I'm like orange and blue. Yeah. I still think. Yeah. Yeah, right. Max Burger Factory, like his old Apple S. Yeah. Like with the floppy. Yeah. But I was like, I forgot to call it. Yeah. Windows machine, so I'd be on the Windows and I'd be like, what do I do? Like on the Windows, I was so confused. Yeah, like, yeah. A lot of the same stuff, like something like and tab, like one. I do have to find like that, like that was like the only thing I could do. Yeah. And yeah. Like solitaire. Yeah. For like birds. My grandpa was actually like lecturing. We would like get like old like black screen with green. Yeah. I gotta finish it all first.
Coming to Eric. So we got a question.
Oh, for sure. We're used to. I no, I. The rest of the figure. Yeah. But she's in that class.
Okay, I will begin once my co-author and I get settled. But for those that are just sitting down, please enjoy. So, okay, so I will start. So let me adjust the mic so I don't have to play with it the entire time. So hello, my name is Kate Rasmussen, and I'm a software engineer at Lawrence Berkeley National Laboratory. I work in the Computer Languages and Systems Software group, and this is Damien Roussan, who is my group lead at Berkeley Lab, and also, as you will see on the slide, one of my co-authors for this presentation. So first of all, I'd like to thank Damien Roussan and also Dan Bonachea, who's not here, but they're both co-authors on this tutorial. So they've been a great help in preparing these slides and helping me prepare for the tutorial in general. So thank you to both of them for their contributions. And just a little background about me, I work on a variety of projects related to Fortran, which may not be a surprise considering it is prominent in the title of this presentation. But some of the things that that includes contributing to LLVM Flame, which is a Fortran compiler, working on a parallel runtime API, which I'll highlight a little bit later to support Fortran's parallel features. And then also we work a lot with different domain scientists to help them with their software projects that use Fortran, whether they're projects that have been written more recently with newer Fortran features or whether they've been around for decades and decades. And maybe sometimes we're there to help them modernize their code a bit and to help them introduce sort of different software best practices into their development practice. So today I will be talking about Julienne plus assert is equal to correctness checking for functional Fortran. So just to preview what we'll be talking about today, as a background to the software packages Julienne and Assert that we'll be discussing, I will talk about agile and test-driven development in general, which is something that we've already seen highlighted in a number of presentations this week, so that's pretty great. We'll talk a little bit about a multi-paradigm view of modern Fortran. Then we will talk about Julienne, the first software package that is our focus of our presentation, and a use case of it in a software library called Matcha. And then we'll talk about Assert, and then a use case of Assert in Fiats. And then to finish up, we'll talk a little bit about different communities that are available for Fortran developers out there and where to find more information if you are interested. So first of all, I'd like to take a temperature check. That is, I would like to know more about my audience and what your connection may or may not be to the two main topics of my talk today, which are Fortran and unit testing. So I was thinking that we could have people in the room raise their hand physically, and then people on Zoom, you could also raise your hand with the Zoom feature, and maybe my co-author Damon can help me check and count the number of people in the room that raise their hand, or sorry, people on Zoom that raise their hand. But so just to learn more about everyone who's here, raise your hand if you use Fortran. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've got 9 in the room. 5 online. Okay, great. So 14, it looks like. That's amazing. That's a pretty good group. Now, raise your hand if you write unit tests. Okay, nice. Yeah, more or less some people, but there's a good number there. We've got a couple online as well. 4 online, it looks like. Now, I'm wondering if this question will have more people than the one we just asked. Raise your hand if you work on a project trying to introduce more unit testing. Okay, I see more hands. I see more hands. That does help me a lot. And it clearly means that unit testing is a subject that is out there and is something that we are concerned with and we need to talk about, but something that perhaps we're not all doing as much as we would like to. Like I said, we've already heard in presentations this week that there are projects that are trying to introduce more unit testing, and it certainly has been a theme, which is great because that's what we're going to talk about here. So just to provide some background, some of this might be a little bit of a repetition from things that we've seen in other presentations, especially the keynote on Monday, but refreshing is always good. So let's talk a little bit about agile and test-driven development in general. So we again heard mention of the waterfall model in the keynote on Monday. But the waterfall model is indeed a more traditional style of development, which begins with requirements. So writing down all the things that you know that you will need for whatever particular piece of subject software, and then moving on to design. Based on those requirements, then you might start to design what the software will look like. And then only then in this waterfall model do we then move into implementation. So hands-on keyboard coding the design. And then after the code is ready, then you might begin to do verification, testing, making sure that things are working, and then it can move into a maintenance phase. But because this is a very linear process, it is more open to issues that might appear, but might only appear late on in the process and can end up being pretty costly if you aren't able to catch things early on. So we have here a example that I grabbed from presentations that I've seen Damien, my co-author, present before, because it's a pretty salient example of when this can go wrong, and that is the NASA Mars Climate Orbiter. So the development of the climate orbiter was done in more of a waterfall model process, and it ended up that then this was lost in space because of a measurements and units issue that wasn't identified until late on in the process. And so then all of that time and effort that went into this was unfortunately lost because of that issue. So this is just an example of why something better might be working in more of an agile approach. So now we do have a lot of different agile development practices, which we could consider as more of a modern approach. So one thing that we like to highlight is that agile development practices and tools are quite lightweight. And I do consider agile development to be a topic that covers both the tools that one uses and then also just general practices that one might do in your workflow and in your daily life. But yes, as I said, these things tend to be lightweight. The purpose of them, hopefully, are that they are easy to learn and easy then to adapt into your workflow. Importantly, they're quite iterative. Iterative is a word that I almost never used in my daily normal life before beginning work at Berkeley Lab. And now I use it so often in my work life that I say it just in general in my vocabulary. And I've been made fun of by my friends in a lighthearted, loving way, of course. But yes, everything is iterative, as I think we probably all can agree on. So when it comes to agile development, the iterative process is that we release often. You can identify and fix problems early, and then that means you can also respond to change quickly. And I'm sure we all know that the environments that we work in are very dynamic. We have compiler versions changing, which change different things that can or cannot be compiled in your software packages. And then if you're moving from one operating system to another, if you're moving from using one machine to another, all of these things are very dynamic in the software environments that we live in. And so you need to be able to have this iterative process to adapt your software quickly and frequently. One of the practices that we like to talk about in agile development is pair programming. So this is one thing where you can work interactively with somebody. You might have one person with the hands on the keyboard coding while the other person is watching them, whether it's on Zoom or in person, and then being able to give quick feedback and also maybe doing something on their own on their side. But pair programming can be great for collaboration where you can identify needs really quickly. You don't have to wait and go back and forth on Slack messages or email chains. You know what you need while you're in there coding, and then that can be great to help move progress in the software quickly. So some of the tools that I wanted to highlight that can be part of the agile development process are things like automated documentation generators. So something like Doxygen is probably pretty familiar to a lot of people here. There's also Ford. So Doxygen has support for Fortran, but Ford is a documentation generator that is specifically designed for Fortran. So if you're ever having issues with Fortran code that you're trying to generate documentation for from Doxygen, you might try Ford just to see if that resolves the issues. And of course, distributed version control makes all of our lives easier, I think, once you get to understand some of Git. So the usage of Git, and then obviously GitHub, GitLab, Bitbucket, et cetera, are really great. Something that we do a lot in our work is try to help scientists who have maybe learned a little bit of programming 2 decades ago or so, or maybe even 3, to do their science. We try to encourage them to learn things like Git because that really helps. It's such an important, obviously, tool of the modern software development process. And so we spend a lot of time trying to help people that are very uncomfortable and nervous about adapting Git to help them become comfortable and get to using it, because it does, I think probably people will agree, make things better. And then of course we have IDEs as well that can be considered part of the agile development process. So just some more practices within this agile development would be test-driven development. So again, test. One thing with test-driven development is that you're not actually necessarily writing the code first, you're writing the test first. So say you have some software and you know that there needs to be a new feature that a user is asking for. Don't try to go write don't try to go write the code first for that feature. Try to write a test for that feature, which will then of course fail because you don't have the implementation for that feature yet. So if you write the test first and then you write the minimal passing code to get that test to pass, then that can be a really great way to develop your code. And that also helps with test coverage. If you're writing the test first and then the source code sort of later in that kind of process, then you're not writing source code that is missing tests that then can, have the possibility of introducing bugs, et cetera. So, and then of course you rinse and repeat. One thing with testing in general, unit testing in general, is that if you write them a certain way, they can almost be kind of a requirements specification for your code. So we like to encourage that as well. One practice that we definitely prefer in our work at my team at Berkeley Lab is to have a suite of unit tests that can run in seconds or minutes. So obviously there's a lot of different software packages out there that have maybe regression testing or different testing that will take a full day to run. And those tests can be really important and necessary. But we also like to have a suite of unit tests that as we're developing, we can just constantly be running them. So I make a change, I run my unit test. I make my change, I run my unit test suite. And then that can be really helpful to catching things early again. And alongside that, of course, then we can have CI and CD, continuous integration and continuous deployment, where then we can merge frequently the changes that we're making and then automate that testing using the unit test suite. And you can have it such that it tests every merge or even every push to a repository. So we obviously highly encourage the usage of that. So since this talk is focused on a unit testing framework for Fortran packages, and since Fortran is sometimes viewed as a less modern language, though we try to move away from that idea. But in order to move away from that idea, I wanted to highlight some things that Fortran offers and show that Fortran provides a variety of features that will support different programming paradigms. So one thing that Fortran is, I think, famous for is great array support. Fortran has been supporting lots of complicated mathematical computations with its multidimensional arrays for decades and decades, and people that use Fortran for that purpose, I think, already know and love that. So Fortran can support array programming through the multidimensional arrays, allocatable arrays, array statements, elemental procedures, and more. So please do use all of those things, especially elemental. I think my team and I don't see the usage of elemental procedures out there as much as we think maybe could be beneficial. So just to highlight that. Fortran also, as it has continued to add features to the language, has added features that support object-oriented programming, of course, so with derived types and polymorphism, et cetera. And Fortran also has features that can help people that want to program in a functional programming style. So we have the pure and simple keywords that you can use to decorate procedure definitions, which then allows the compiler to restrict certain behavior within that procedure. One thing that Fortran is definitely not known for in our experience, though we hope this will change, is that it's a natively parallel language, and it has been since 2008. And I don't know if you checked the calendar lately, but it's not really 2008 or any years close to that at the moment. It's been a number of years since this has happened, but we do like to highlight it because people are not always aware. So with Fortran, you can natively support both multi-image parallelism instead of, say, using something like MPI, and loop-level parallelism instead of using something like OpenMP. So for the multi-image parallelism, Fortran provides you a single program, multiple data version of parallelism, which you can use through the features coarrays, collective and atomic subroutines, teams, events, notifications, and more. So that is something that we like to highlight. With loop-level parallelism, instead of using OpenMP in Fortran, you could use the native feature do concurrent. And the benefits of using these features can be that sometimes they can be easier to write and maybe even perform better, because if you have a compiler that is optimizing various things, it might be that the code that you write, if you were to use these native Fortran features, might run faster because the compiler can optimize things. And then also, you might be using a specific compiler that sits on top of a different runtime abstraction, such as GasNet instead of MPI, and so you can also compare performance there. So that can be one benefit, but if I'm going to discuss benefits, I have to discuss drawbacks. So unfortunately, one drawback of using these features is, of course, compiler support. I say, of course, might not be obvious to those of you in the audience unless you've used it, but if you've used it, I think you would certainly know. So at the moment, on the loop level parallelism side, Do Concurrent has some pretty good compiler support. So there are currently 3 compilers, which I have listed here, NVIDIA, Intel, and HPE, that do support automatic offloading to GPUs. So that's pretty great. And we do hope that more compilers will continue to add that support. On the core side, the support is definitely more spotty. So just be aware of that. However, my team and I at Berkeley Lab, we are contributing to Prif, which is a parallel runtime interface for Fortran, and Caffeine, which is a runtime support library. And so we are trying to help introduce support for Fortran's native multi-image parallel features to hopefully we're targeting LLVM Flang and LFortran, which are both open source compilers. So we have hope for the future. We're trying to work towards that, but just do be aware. Okay, so I will just quickly go through these things. Another thing that we don't see talked about as much when we hear talks about Fortran are some really useful intrinsic functions. And when we work with scientists, we find that people don't always know that these are available. So just to highlight some really quickly, some things that could be useful for you if you're programming in Fortran would be find loc, pack, count, merge, and index. I won't go into any detail, but this slide deck in general has a bunch of links that I highly encourage people to download and click through later if you want to learn more about Fortran. So I've provided a bunch of links, but just note that with the intrinsic functions from Fortran, it can do some really powerful things if you're combining the intrinsic calls especially. And to that point, I will just give a little teaser of something that I presented in a presentation last month. And this is an example that Damien Roussan wrote and helped me develop, which is where we took this 37-line code block and we converted it to a much, much smaller number, all by just using a couple of intrinsic Fortran functions. And on this slide, I have a question mark to say, who knows how many lines we can get down to from 37 to who knows. But since we're all here in the room and we're all friends, of course, I will say the answer is 2. So you can click through this link here and you'll find a YouTube recording of the presentation that I gave, and I timestamped it so you can go to this example. But yes, just by the usage of, I believe it was only 2 Fortran intrinsic functions, we can reduce this 37 lines of code to only 2 lines of code. So quite powerful things out there that not everybody's aware of who's using Fortran, so wanted to highlight that. And this is a list of other just additional functions that we have found have been useful in our collaborations with different scientists. So again, I won't be going into detail, but please click through these links if you would like to learn more. So now to the meat of the presentation. So Julienne, and we have a quick link for go.lbl.gov/Julienne, which goes to the GitHub repository if you would like to check that out. So I'll pause for just a second and also to take a breath and drink some water. It's a good opportunity. But now on with Julienne. So we are all told that we need to eat vegetables, right? I think that's a pretty common message that we receive in life. As software developers, I think we are all often told, again, back to unit testing, that we should develop unit tests. And some people like eating vegetables, some people don't. Some people like writing unit tests. They're out there, I promise you. Some people don't like writing unit tests. So the name of this package is related to vegetables. So does anybody happen to know, other than this person sitting on the stage with me, does anybody happen to know what you call it? It's both a noun and a verb in English. What you call it when you thinly slice vegetables, as this person is doing in the photo. Julienne, wow, thank you. It is absolutely correct. It is Julienne. So Julienne is a lightweight unit testing framework, which was in fact inspired by a different package called Veggies. And so as this is more lightweight, we are Julienne. And we will talk more about what this package can do for you. So as I said, Julienne is a Fortran unit testing framework. And it uses the template method object-oriented design pattern to specify how users can describe tests and package the results for reporting. So Julienne tests can include serial and also parallel Fortran features in those tests. And we will see some examples of what Julienne tests look like. But in each Julienne test, the unit tests reside in a collection of unit tests. And then you have a main test program, which invokes each of those collection of unit tests. And Julienne's output is designed in a way to make it easy for your unit test to read almost like a specification for your code. So in that way, your unit test can kind of be self-documenting, which can be really great if you write them in that way. So earlier, we heard a brief mention of FPM, the Fortran Package Manager, from Damien when he was asking a question in an earlier presentation. And Julienne is a FPM package. So in order to just preface what that is, I will talk briefly about FPM. So FPM does stand for the Fortran Package Manager. It is both a package manager and a build system. The source code for FPM itself is written in Fortran, which is pretty great because then you have the people who are likely to use this software, namely Fortran users, be people who can also contribute to the package itself, to the source code itself, because it is written in the language of its users. So as such, it is maintained by the Fortran developer community. And I will say that people who do love to use Fortran are some of the most passionate people that I know. So yeah, there are people out there doing great work in the Fortran developer community. One highlight, and I do say highlight because it is something that we love the most about FPM, is that it automatically detects file dependencies. So as we know with a lot of different systems like Make, you will have to list things often in a specific file ordering to make sure that things are compiled in the order that is needed to deal with those different file dependencies. FPM does that all for you, so you don't have to think at all about the order of compilation that is necessary. So that's really great. So FPM does support both Fortran and C source code. It may potentially work with some C++ code, but if you're trying it out on C++ code, just know that it might run into issues. But for Fortran and C, it's got pretty great support. FPM itself is also very, very easy to install. So again, the talk earlier, we were talking about our software package is easy to install or not. FPM itself is very easy to install. It's available through various package managers, but also if you're using G-Fortran 13 or later, I specify that because there are certain G-Fortran extensions that are needed for this. But if you are using G-Fortran 13 or later, there is a version that is in the FPM releases, which is the entire source code of FPM all put into one single file. And so if you can just compile that one single file, and then now you have FPM. So to go back to Julienne, I wanted to highlight what is the test output that you get with Julienne. So with Julienne, and we'll see some screenshot versions of this, so don't worry too much about just seeing the text. We'll see some examples. But with Julienne, the test output includes a test subject. So often the test subject is referring to a class or a type-bound procedure. It then states the expected behavior, and then it will, of course, tell you the test outcome, if it passed or it failed. And if it fails, then it provides diagnostic information. And as I say, we will see some more examples in the use case with Matcha. One thing that I also wanted to mention is that I briefly said already, but you can test Fortran's parallel features in Julienne unit tests. So I just wanted to highlight that Julienne cannot run tests in parallel. However, it can run parallel tests, and that is obviously distinct. But for the parallel tests, that means that you can write Julienne unit tests that invoke and use multi-image Fortran features. And when that happens, that means that every image will run every test, but Julienne will only report that a test passes if it passed on all images. And then only image one will output the results of the tests. So just wanted to make you aware of that. Now, okay, now this is the place where hopefully this will work well. And I might need to talk quickly because I won't be able to pause. This is a video, but before I start the video, one feature of FPM, which is really great, is that there's an FPM new command. So if you type in FPM new, it will automatically create a GitHub enabled repository with a bunch of boilerplate stuff, and then you can start to move in your source code. So in this example, I will show you how to get started with Julienne. So what I'm going to do is I'm going to copy an example test directory from the Julienne repository and move it into a new FPM project, and then run the tests and highlight some features through there. So let's see how this goes. I think this will play. Okay, great. Okay, so I will try to narrate appropriately. So FPM new example project just creates, as I said, a boilerplate And just to show you what's in there, there's an app directory, source directory, and a test directory with just some basics that you can get started with. The test is just a program that has a print statement, so it doesn't really do anything. And this is an FPM TOML file. This is the manifest. This is populated with, as I said, just automatically what you need. I'm adding the Julienne dependency and deleting a bunch of other stuff that I'm happy with the default values. And as you will note, that was just a couple of lines. That's your build system, essentially, with FPM. And it might need to be more complicated for your project, but for this one, that's literally all I need to then build my project. Now I ran FPM test, and as you can see, it just printed out a print statement saying put some tests in here. So now I'm going to copy over the example tests from the Julienne repository, as I said, and move them into my test directory. And then I'm going to move the source code from that example test directory into the source code within the FPM project. So I'm moving that around to the correct location. And then now I'm running FPM test again. So now this is going to run now it's automatically rebuilding, and it's rebuilding all of the dependencies for Julienne. And then it fails because the example is designed to fail, and so that you can see some of the output. And we'll go into more to output outside of this video, but you can see that it failed, and you can see the description of what was supposed to happen and then what did happen. So expected a value of 0, got an actual value of 1. And then I'm going to go in and update the source code, because obviously if you have a test that's failing, you need to fix some source. So I'm going to go into the source code, which, as I said, was designed to fail because it is a pure function called 0, but it returns the value 1. As you can see, the immediate problem. So I'm going to update to the correct expected value, change the name of the identifiers just to make sense, and then run FPM test again, rebuild what it needs to rebuild, and then you can see what a testing Julienne test suite looks like, Julienne test suite looks like. And I believe that is the end of the video. Yes. Okay, so now just to review what we just saw. So if you're looking at this slides later without the video, what we saw was using FPM to get a new basic project to then be working from. All I had to do to add Julienne was add that one line to the FPM TOML file to add that dependency. And then I copied the example, I moved around the source code, and then I ran the test, and I fixed the purposeful error so that the test would pass. So what happens when you want to write your own unit tests with Julienne? So when you want to write your own unit test, you start by writing a function that returns a test diagnosis T object. So the test diagnosis T object is from Julienne. Julienne is a unit testing framework, so it provides you those things. So a test diagnosis T object itself contains a condition in the form of a Boolean expression that must pass for the test to pass, of course. And then it also contains a diagnostic string that is reported if failure occurs. So this is where you have a lot of control over what the output will look like. And Julienne provides a number of different string functions that will allow you to convert things to strings so that you can then put them in your diagnostic string and design exactly what you want the output to the terminal window to be when a test fails. So we just saw the FPM example, the Julienne example, which just had one function called 0 in it, and 0 did, as one would expect, return 0 once we fix the source code. So for this example, I have written a new very basic function called increment. It does what you might expect it to do. It increments an integer. And now to write my new unit test for that very basic function, I have written a check increment function. So again, when writing a Julienne unit test, you start with a function that returns a test diagnosis T. So here I've highlighted in green the two different arguments to the constructor for test diagnosis T that I need. So the test passed, again, that's the Boolean expression, the condition to check for whether the test passes or not. So obviously this is a very simple example, but all I'm doing is checking that the actual result is the expected result. I have passed the increment function the value 7, so of course I expect the value 8 back. I'm checking that. And then the second argument to the constructor is the diagnostic string, in which I am then saying my expected result is expected result, my actual result is actual result. So if that fails, then I get that information. But again, the diagnostic string can be whatever you want it to be. So you have a lot of control with that. So what happens when you want to write your own collection of unit tests? Or sorry, I skipped ahead a little bit. What happens when you want to add that unit test to the Julienne testing framework to make sure that it is invoked? So we just wrote the unit test, the check increment. So then what I need to do is I need to update the results function. And since in my example that I showed in the video, I already had a results function for the collection of unit tests, all I would need to do is go to that results function and then add a new test description T object. And the test description T object has two parts of it. So to construct that, I need to write a description of the unit test, and then I need to pass it a function pointer, in Fortran, a procedure pointer to the unit test function. And so then I add that to a list, to an array within the results function, which is the array that lists and invokes each of the unit tests for that collection of unit tests. And to show you what that looks like, I have that here. So in green, I have highlighted the things that I need to add, or the things that I have added to be able to then get my new check increment function unit test added to the results, added to the collection of unit tests so that it gets invoked. So I have a procedure pointer there, and then I have the test description, and then the passing of the procedure pointer. And note, this is the version that you would need to do if you were using G-Fortran, because unfortunately there is a G-Fortran bug related to passing procedure pointers as actual arguments. But since G-Fortran is a very popular compiler out there, I have noted what you would need to do with G-Fortran. If you were to use a different compiler such as LLVM Flang, this is the only things that you would need to add that one unit test, is just construct one single test description T. You're writing the description string, and then you're passing it, and then you're passing the constructor of that object, the procedure pointer. So then now that we've added, theoretically, a unit test to a already existing collection of unit tests, what do we do to then write a new collection of unit tests? So one easy way is to then copy the example, which has a collection of unit tests, to copy that and then change things for your purpose. But the things that you will need are, you will need to create the new test object for the collection of unit tests. And this test object extends the test T object from the framework. And within the module that contains the definition for these things, you need to have a subject function. The subject function just returns a string, which is a description of the collection of unit tests. And then you need to write the results function. So we saw an example of that here, results function. So you need to write something similar, which lists and invokes each of the unit tests through the test description T objects. And then to invoke that, you then, in your test main program, you can invoke a collection of unit tests by calling the report function on the new test object that you have created. So you can see here an example of a Julienne test main program, and I have highlighted in green the use statement where you bring in the definitions for that collection of unit tests, and then you just have on line 15, call specimen test report, passes tests, and that is then how all of the Julienne testing framework takes what you added, what you have written yourself, and then gives you your test suite. So one functionality rather that I wanted to highlight is that Julienne provides the ability to skip some tests. So as I mentioned earlier, we like to have a very small unit test suite that you can run. Well, the unit test suite doesn't necessarily have to be small, but we want it to be able to run quickly. But for us, sometimes we do have a unit test suite that can run in a couple seconds, but it might have, I don't know, 20 tests, 20 unit tests in them. But if you know that you've just edited some source code that only focuses on a particular part of your code base, and you only want to run those tests, Julienne will, I've actually started to talk about a different functionality, which I will discuss later, because there is some sort of nuance between the terminology that we use in terms of skipping tests versus a function that I'll say later. So I've walked down the wrong path there. So just to rewind a little bit, you might want to skip a test because you might have a test that invokes code that causes a either compiler runtime error or a compiler a compilation error. So if you have some compiler bugs that create either compile time or runtime crashes, obviously that means that you can't run your tests. And so in order to work around those things, Julienne has the functionality to skip those tests. So you can still run all of the other tests if you know that there's a known bug. And we would obviously recommend that if you do this, then you would note that in your README somewhere so that users know, okay, with this compiler, this particular test is not being run. But we do have to work around compiler bugs a lot. And Damien likes to say that he writes maybe at least one compiler bug per week and then reports it. So it is something that we deal with a lot in our lives. So this functionality can be super useful if you, like us, run into compiler bugs. I was thinking at the end, but if anybody has a burning desire. Yeah, please.
There's a hand raised. Maggie, did you want to unmute yourself? Okay, maybe that's left over from the question earlier.
Okay, could be.
Sorry.
But thank you. If anybody else raises their hand, I can take a break or stop for questions. So in order to skip a test, what you need to do is, earlier we saw how to construct a test description T object. So what you do when you want to skip that test is you just, instead of passing it that procedure pointer to the constructor of that object, you don't pass it anything. So you only will pass the test description. And that means that then that test will not be run. So in blue here, we have highlighted what you might do in your code where you have macroed away. For one compiler, you are not passing, namely in the else clause here. For one compiler, you are not passing the procedure pointer, which means that that test will not run. And then in the initial clause, you are passing that pointer. So that, as we can see here, there was a G-Fortran bug that we had to work around. So as you can see here, if you are running this test, or if you're compiling this code with a compiler that is not G-Fortran, then then this particular test will run. And if you're compiling it with G-Fortran, this particular test will be skipped. And what that looks like is this. So here we have some Julienne example output. And I have highlighted here what it looks like when you fail. So this is an actual failure. And I just had to kind of hack the code to get an example of what a failure looks like, because of course we have this source code working correctly. But when it fails, then you can see that they're highlighted in green at the top. In this particular diagnostic string, we are printing out the expected values, which is an array, and then we are printing out the actual values, which is another array, and you can see that they differ, and so that leads to a failure. And you can see that with the description string, you can see it specifically fails on yielding a comma-separated list of double precision numbers. So again, we've got all this rich output data for you to help you find out what the problem is. Now, in the green highlighted box on the bottom, that's showing what happens when you skip it. So again, this is skipping a test because of a compiler bug. So this is what happens when you compile this code with G-Fortran, and it skips those two tests because those two tests happen to happen to stumble upon a compiler bug. So as you can see here, then at the bottom we have printed out that 6 of the 9 tests passed, but that 2 tests were skipped. So filtering tests, this is the thing that I kind of went, as I said, when I walked down the wrong path, I was talking about filtering tests. So as I said earlier, you might have a test suite with a bunch of tests, but you might only want to run a subset of them because you know that that's the code that you're currently editing in source. So in order to do that, Julienne provides you a flag that you can use, which then will only invoke specific subset of unit tests. So what that looks like is it's a dash contains flag, and you have to pass that flag to FPM. So I've written down what the full invocation looks like. So it's FPM test -- contains, and then you just write a string. So whatever string that you want. And so what happens then is that on this previous slide, where you have all of those descriptions of string, all those descriptions of tests, when you use the contains flag, it will search all of those descriptions for that character string that you have passed it. And if it finds it, then it will run those tests. And if it doesn't, it will not run those tests. So you can run the entire test suite, look at the things that you know are in the description strings and be like, okay, I only want to test things related to numbers, which I will show you here. So here I have done FPM test -- contains number. And then as you can see, the first 4 tests within the format string subject, they all run because they all contain descriptions for each unit test, which contain the word numbers. but the rest of the tests did not. So then you can see that the test result t-type, 0 of 0 test pass, right? Nothing failed, nothing was technically skipped, because again, this is where there's a nuance between what we mean by skipped and filtering. So no tests were skipped, but those tests didn't run because they weren't part of the subset that you wanted to run. So that's what filtering tests looks like. And I've highlighted there. Those are the only ones that have run. Okay, so use case. What does this look like with Matcha? So to begin, let's talk a little about what Matcha is. Now, in a presentation earlier this week, we heard that there are people in this world who are also really great at coming up with acronyms when writing software, when coming up with names for software packages. In my life, the person that I know that is best at doing this is this gentleman to my left, Damien Roussan. He's incredibly creative when coming up with acronyms. And so you'll see two examples of that in this presentation. First is MACHA. So MACHA stands for Motility Analysis of T-Cell Histories in Activation. And it's fun because Matcha, when it was originally being written, kind of had a relationship to another package called Caffeine, which I mentioned earlier, which also is an acronym, which I do not know off the top of my head, so I cannot repeat it for you, but it's pretty great. And obviously matcha, the drink itself, has caffeine, so we have all sorts of cool little fun connections here. But matcha is a T-cell motility simulator. It is developed at Berkeley Lab, but also in collaboration with Northern New Mexico College. And the goal is to design virtual T-cells that move like biological T-cells. So let's talk about some things that Matcha needs to ensure that it's doing the correct behavior. So first, I'm just going to highlight a couple things. There's obviously a number of things that Matcha needs to ensure, but some of the things that it does need to do is it needs to ensure that a subdomain T object correctly computes a concave Laplacian for a spatially constant operand with a step down at boundaries. And it needs to do other things related to the subdomain T object, but that is one important thing it needs to do. It also needs to ensure that a T-cell collection T object correctly constructs its position in the specified domain, and it needs to check some other things. And then it needs to ensure that a matcha T object can match simulated distributions to empirical distributions. So I'm not a matcha developer, so what all of that meant, I don't really know. That's not my domain speciality, but I do know that there are unit tests for that. And that's the important part of it that I am concerned with in this presentation. So Matcha uses Julienne unit tests to help validate those behaviors. We will see what that looks like here. So here we have a unit test. So as I stated earlier, a unit test for Julienne is a function that returns a test diagnosis T object. And so in order to zoom in on the important part of that, we have that here. So here you can see that actually with this example, it is returning more than one test diagnosis T object. It is returning 2, which is something that Julienne provides support for. Depending on compiler, there might be a bug related to that as well, but if you run into issues, please contact us. But yes, you can return more than one test diagnosis T. And as I said again earlier, just to repeat, what you need to do to construct those objects is the condition for the test to pass, and then this diagnostic string to be presented to the terminal if it doesn't. So here, for Matcha, this unit test is testing to make sure that the expected max frequency matches the actual frequency, but it is doing that within a tolerance, of course. And then also that the expected max speeds match the actual max speeds. Again, we have set a tolerance. So that is what that looks like, what one particular unit test looks like in Matcha. Now here we are looking then zooming out from the unit test, looking at the unit test collection for Matcha, for the Matcha T type. So as you can see, there is a test descriptions array. And that again, as I said earlier, we have test description T objects, which have the description of that unit test, and then a procedure pointer to the function that defines the unit test. And so the unit test function that we saw on the last page, now we are seeing it here in the results function. It is being returned as a part of the results function in that array, which means that it will be invoked. And this is what it looks like when you execute the Julienne test suite. So again, the output kind of reads like a specification. So we can see that for Matcha, the subdomain T object passes, the tests for the subdomain T object passes on computing a concave Laplacian for a spatially constant operand with a step down of boundaries. Huzzah for that. And I won't read the rest of it, but again, just to note, the way that Julienne formats it output is to help make it easier, make it very easy to see and kind of read like a specification for your code. I've just highlighted sort of the terminology that I've been using throughout the presentation related to the different parts of the unit testing framework. So in green here, or in these boxes here, we have the description strings that describe the subject of the collection of unit tests. And then here I've just, excuse me, just noted one particular description of that particular unit test. And that's in fact the unit test that we looked at in the example. And then you can see here the results of that collection of unit tests. And then in aggregate, the results of all of the collection of unit tests together. So again, 7 of 7 tests pass. Good job, matcha. Okay, so I specifically put in this slide to force myself to breathe and to take a drink of water. And I'm pretty sure you are all doing that already, but I encourage anybody who needs that reminder, please do as well. So pause for H2O break and put my boss on the spot to come up with a joke. Exactly. Okay, now that we have refreshed ourselves, let's continue to talk about the other main piece of software that we are discussing today in this tutorial, which is Assert. So again, we have a quick link to the Assert repository, go.lbl.gov/assert. I will pause for a little bit longer. Okay, so in order to talk about Assert, we wanted to give some background as to why Assert even exists, why the people at Berkeley Lab that I work with began to work on that software package, utility, I would rather call it. But the motivation behind it is to support functional programming patterns. So in order to discuss that, I'm just going to talk about a high level things that you might already know, but what is functional programming? So if you were to want to code in a functional programming style, the recommendations would be to write pure procedures, especially pure functions with no side effects, write things that are referential transparent. That is, when you have a function that you pass in the same arguments, you would get the same result if it were to be referential transparent. And then another recommendation would be to define immutable state. So in Fortran, what that looks like specifically is using the associate statement with expressions. The consequences, though, of in Fortran specifically, of writing code in a functional programming manner, according to those recommendations, would be that you cannot use certain statements such as write, print, stop. However, in Fortran, you can use error stop in procedures that are pure. And so I say these recommendations are things for the functional programming style in general. In Fortran, as I mentioned earlier, there are the pure and simple keywords which decorate procedures that you are writing, and those enforce certain behavior. But just to note that, so simple is more restrictive than pure. Pure was introduced first into the language. I don't know off the top of my head the year, but then in a later standard, simple was introduced, which is basically pure, but with some additional restrictions. But even simple doesn't necessarily meet all of those recommendations. It doesn't necessarily ensure that all of those recommendations on the slide are being followed. So just to note that if you follow those recommendations, some of that will be on you because the compiler won't be able to check that because simple doesn't require all of those things. Namely, simple procedures in Fortran don't have to be referentially transparent. But if you are using Fortran to program in a functional way, then you would probably be using the pure and simple keywords to at least allow the compiler to check certain things related to that. And when you do use those pure and simple keywords, that is when you are not allowed to use write, print, and stop, but you are allowed to use error stop. So some pros to using functional programming is that it can clarify data dependencies, which can be really important and helpful for parallelizing. And in Fortran, only pure procedures can be invoked inside of a do concurrent. So if you're wanting to use loop level parallelism, again, the native version of loop level parallelism in Fortran, you are going to need pure procedures. Cons are that when there's no output when you're debugging, because again, you can't put in a print statement, you can't put in a write statement, so there's no output. However, there is the exception, which is error stop, because error stop does produce output. So that well, and in addition to the error stop exception is that there might be a useful utility which allows you to do output. And that's where I say wink, wink, because we'll be seeing that in a second. But first, I wanted to talk a little bit about programming by contract. So programming by contract enforces various constraints. You can have preconditions, which are correctness requirements that must be true before a procedure executes. And then on the opposite end, we have postconditions, which must be true after a procedure executes. And then we have invariants, which are correctness conditions that must always be true. And in C and C++, as you probably know, or if you are a C or C++ developer, you would know, you can enforce constraints using the assert.h header library that is part of the C standard library. In Fortran, we don't have an equivalent, but in Fortran, constraints can take the form of logical expressions, and they can then be enforced, again, wink, wink, if you have a utility. So hopefully, you will know now that that utility is the one that I'm discussing in this section of the presentation, which is assert. So assert is a Fortran assertion utility that allows for diagnostic output. The motivations for this were, again, to mitigate against a reason that Fortran developers often cite for not writing pure procedures, which is their inability to produce output in normal execution. And another motivation is to promote the enforcement of programming contracts, as we discussed on the last slide. So assert is very useful because it can be called in pure procedures. Now, how that works is because assert is sort of built on top of error stop, which, as we saw, is one of the only things that gives output that in Fortran you can use in pure and simple procedures. So the provided assertions from the assert utility are function-like preprocessor macros that by default get replaced by nothing. So it is kind of an interesting state where this utility does nothing by default. But we want that because if in your normal development workflow, we might not want certain types of assertions because then your code can run faster without those assertions because you're avoiding certain runtime overhead. But then this library comes into its use when you're needing to debug. And so in order to turn on the functionality of the library, you would just use the D assertions flag when you're compiling. And kind of tying back in with the discussion earlier of CI, you could have special CI runs. For example, in your GitHub Actions, you could have one particular CI run that runs with that flag always turned on. So maybe on every merge request, you have to pass that particular CI where those assertions are turned on. So getting started with assert, here we have a long URL, so I don't expect you to type it in, but if you want to check out assert after my presentation, you can look at my slides and follow that. But there is an example which shows you some simple ways that assert can be used, which maybe will help get you started. And I've copied some onto this slide, but one thing to note is that in any file where you want to use assertions from the assert utility, you have to have this include statement and then this use statement. So please note that. But for the assertion utility, you get three, again, function-like preprocessor macros, call assert, call describe, and call assert describe, and call assert diagnose. And as you can see here, they differ in the number of arguments. Call assert only has one argument, which is, of course, a condition that you want to pass. And then if you fail, that's when there's a problem. So we have 1 is equal to 1, which I believe we can all agree is true. And then call assert describe has 2 arguments. So again, the first one is that condition. The second is a string. So again, you can put whatever you want in the string to describe the situation that the assertion that you're trying to assert. And then the third, call assert diagnosis, provides a third argument, which can allow you to have really complex structured output to the terminal. So that is also very useful. Okay. So what to expect upon failure. So again, if you don't do anything, by default, the assert library will do nothing. But if you use that special flag, the D assertions flag, then what will happen is if it fails, it will look like this. So I've given this example. So I have a call assert describe, true is equivalent to false, which again, I hope we can all agree, it will always evaluate to false. And then I've passed it that string, I'm breaking the Boolean basics. So if I were to compile with the D assertions flag and then run that code, when that code is encountered, then I will get an error stop again, because like I said, assert is built on top of error stop. And then I will see I broke the Boolean basics in file, and then it gives me the file name and the line number. Now, because the assert library uses error stop, it means that the exact output might look different for different compilers, because different compilers have different output for things like error stop. So this is one example. I believe this was with G-Fortran. But that's what it will look like. What to expect when assertions pass? Nothing. Yeah. I just wanted to highlight that, that if you have the assertion flag turned on, and if all of your assertions pass, then you will of course see nothing. Nothing will happen. That is remarkable, which, yay, means all of your assertions passed. However, after I made this slide, I also realized that if you're specifically turning on the assertions, it might be because you're trying to debug your environment. So if it was for your CI run, where you're turning on assertions just to check everything and nothing happens, that's when we get to say hurrah. But if you're trying to debug and you turn on your assertions and nothing happens, that might mean that you just have a bug that is harder to encounter. But in order to stay optimistic, then I continue to highlight this little happy emoji and say, well, yay, now you have a puzzle to solve. Something that we all deal with a lot in our work, I'm sure. So to discuss a little bit more of Assert, we have a brief example with fiats. And here we have another acronym, again, written by or named by Damien. So as we all know, machine learning and AI will continue to have a huge impact on HPC. You can hardly go anywhere without hearing people talk about machine learning and AI. And of course, most people first think of things like Python, PyTorch, when they think about machine learning and AI. But I just wanted to highlight that Fortran does have packages written in Fortran that can do deep learning. And this is one example, is fiats. Fiats is also developed at Berkeley Lab, and Damien is the primary developer of fiats. So the name fiat stands for Functional Inference and Training for Surrogates. But again, because Damien is so talented, it even has a second name, which also works, which is Fortran Inference and Training for Science. So fiats does training and deployment of neural network surrogate models for computational science, and it does automatic parallelization of batch inference. And if you would like to learn more, I will highlight this a couple times, but there is a talk Damien is giving tomorrow, so please do attend. But for this presentation, I just wanted to note that in fiats currently, assertions are used for validating some input data that it's in the correct format. But importantly, it's also validating the construction of the layers of the neural network as it goes along. So just to give a quick example, this is a procedure which is source code from fiats, and it is constructing a layer within the neural network. And here I have highlighted some calls to assertion, which are making sure that certain things are in the right form such that the layer can be constructed correctly. So just a quick highlight of what that can look like in Fortran source code. Again, this is my special slide all to be an advertisement. So tomorrow, Damien will be talking and we'll be giving a talk called Cloud Microphysics Training and AirSL Inference with the fiats Deep Learning Library. It's tomorrow at 8:30 a.m. early in the morning, but please do join. Okay, so one thing that I wanted to talk about, and because I did my little poll earlier, I do know that there are people in this room and online that do work with Fortran. And for those of you that don't work closely with Fortran yourself, please do think about how this could help people that you know, because even if you don't work with Fortran, you might work with scientists who do work with Fortran, or you might work with a student who is needing to learn something about Fortran, or, so just think about how these resources could be helpful for them. Because again, Fortran sometimes is viewed as sort of a language that's just of the past, but I want to highlight it as very much of the present. And so here are some things that can highlight how vibrant the developer community is. So one thing I mentioned earlier, that we work a lot with domain scientists that have Fortran code, and we might help try to modernize the code. So one tool that we're aware of that can help with some static analysis for Fortran and also for C and C++. But that tool is Cody, and I have linked here again for if you look at my presentation slides later, I've linked here some tutorials that Cody has from their YouTube channel and also from a training that they did at NERSC, which is the supercomputing facility at Berkeley Lab. So please do be aware, there are some really helpful things out there if you do have Fortran code that you want to statically analyze and see if there's opportunities for modernization or improvements or checking code correctness. You can check out Cody. There's also Fortran linter. One of my colleagues used Fortran linter on a project recently where we're trying to modernize some code. There's also things that can help you use JSON, the JSON input format. If you are trying to use JSON input, if you're trying to use JSON files to input your data into a Fortran program, there's some utilities that will help you with that, such as RogFF. There's also isovariant string, which is an implementation of a isovariant string module, which was proposed for the Fortran standard. It never made it, but for people who did want that functionality, they have gone ahead and implemented it, so it can be useful for you perhaps as well. I mentioned earlier Ford. Here's just some more links and link to an example for documentation if you'd like to learn more about that automatic documentation generator that is specifically, again, designed for Fortran. And there are a variety of tools out there to convert fixed form code to free form code. So I didn't highlight one in particular, but just from my personal preference, I always relish the day when I'm working on a project and I get to convert fixed form Fortran to free form Fortran. So if that's a need you have, just be aware that there are lots of tools that automate that process for you. And then I have a grab bag in my grab bag, which is a great, just really incredibly long list. So I have not looked through everything, but I plan to go and explore more of it. But it's a huge long list of things related to Fortran out there that might be useful for you. So thank you to the user on GitHub who has collected that. Now, because we've talked so much about Fortran and features that it currently has, I wanted to just highlight again, just as advertisement, what will be upcoming in Fortran. So Fortran in the next standard will be adding generic programming. So we will have type-safe templates in Fortran. And because of that, they will work significantly different from C++. But that also means that the compiler errors that you will get if you have a bug in your code related to templates will be much, much more comprehensible. So we're all pretty excited about that. Other things that will be added to the Fortran standard are asynchrony in tasks and collectives. And then also Fortran does not have a standardized preprocessor right now. All of your Fortran compilers out there that I'm aware of at least do have a C-like preprocessor, but they're not standardized because it's not talked about in the standard. And so there's an effort right now to standardize that, which will then hopefully make it easier to jump from compiler to compiler and have those preprocessor macros that you use work as expected. So that's pretty great too. I just wanted to note that you might not think that you could be part of influencing the future of Fortran, but if you think that you might want to, I just wanted to note that, well, first of all, Damien and I are both members of the Fortran standard. We are alternates for Berkeley Lab. And as part of my role on the J3 body, which is the US national body, Insights, it is informally known as J3. Part of something that I'm working on right now is trying to make it easier for people to join. So if you have any interest in getting involved with the standard work, or if you know of anybody that has interest in getting involved with the standard work, please follow these links. And if you have any questions, feel free to email me because that's something I'm trying to make that process easier for people to do. And then we have the international body, WG5, which is an ISO body that actually publishes the standard. Okay. So just to wrap up the Fortran community section, there are stereotypes, as I have mentioned multiple times today, about Fortran being antiquated. But I think, like I've already said probably about 5 times, there is a very vibrant, engaged developer community out there. And so I wanted to highlight some places where you can find and interact with that community. If you have questions, fortran-lang.org is a really great website that has a bunch of tutorials. If you're a Fortran user, those tutorials might not be helpful for you because they might cover things that you know. But if you're working with a grad student soon, or again, if you know, or if you're working with a scientist who is now having to use a software package that they've never used before that has Fortran, you know, there's a variety of contexts in which people might need to just come up to speed on a couple different things related to Fortran. Fortran-lang.org is a really, really great resource. It has a lot of tutorials. It has some links to some interactive playgrounds. It tries to give you up-to-date information about compilers. That is a very dynamic world, as we all know, but it tries to keep as up-to-date as it can. It also has links to L-Fortran. Now, L-Fortran is a Fortran compiler and interpreter, so you can do some cool things with that in the web. And then another really, really great resource is the Fortran-Lang discourse. So again, that's a wonderful place to ask questions. If you have questions yourself related to Fortran, you can ask questions. Maybe you're a Fortran expert and maybe you want to go there and answer other people's questions. So just please do be aware. These communities are out there, they're vibrant, and maybe you can contribute to them as well. And then I have a fortran.lbl.gov link, which is just a description that we keep up to date with all the things that we do related to Fortran, which is a lot. So if you're interested, feel free to check that out. And of course, I have to acknowledge that the work represented in this presentation is supported by the U.S. Department of Energy and the Office of Science, particularly the Office of Advanced Scientific Computing Research. So thank you to them, to those funding sources. And then also, as I mentioned when I introduced Julienne was initially inspired by the testing framework Veggies. So I wanted to highlight that Brad Richardson is the lead developer of Veggies. And if you want to learn more about Veggies, we have a link there as well. Now I'm almost done, but just for a couple more. Oh, I don't. Okay, I added something at the last minute, so it has not populated, but that's fine because I will just say it off the top of my head. Just as some quick advertisements. First of all, again, I mentioned this, but just to highlight again, please attend Damien's talk tomorrow about fiats. And also, I am part of the organizing committee for CARLA, which is the Latin American High Performance Computing Conference. So CARLA this year is being hosted in Kingston, Jamaica. It's the first time that CARLA, again, as the Latin American High Performance Computing Conference, it's the first time that CARLA will be hosted in the Caribbean. And as it is hosted in Jamaica, I don't know if you guys know, but Jamaica deals a lot with hurricanes. So Kevin Brown, who is from Argonne Lab, is the general chair of this instance of CARLA. And so one thing that is a big focus, a very particular strong focus of this year's CARLA is a focus on weather science. So I know being at NCAR, we have a lot of people involved in that. So if you're interested in learning more about CARLA, please go to carlaconference.org. And you can learn more about there. There's obviously talks and proceedings. There's workshops, tutorials, various things. So if you want to attend or contribute, there's both in-person, obviously Jamaica, that would be great. There's in-person attendance there. I think will also be a virtual option. So please do be aware. And if you know anybody that might be interested in the CARLA conference, please do spread it around. I had not heard of this particular conference until my boss mentioned it. So I just wanted to highlight that there's lots of really great conferences out there that not everybody's aware of. So I wanted to highlight CARLA. And now we have arrived at my thank you slide. So thank you very much. And if you have any questions about anything that I talked about today, we have a fortran@lbl.gov email, which goes to myself and everybody else on my team that works closely with Fortran. So please do email us. And are there any questions?
Yeah, great talk. And I use the code I work with is overwhelmingly Fortran, so I might harangue you both at some point later this week about general stuff. But in terms of this, I just wanted to know, what do I want to know? I want to know, is there a way to test a lot of times in other unit testing frameworks? Like I want to test not that the code works correctly, but also like assert error, like essentially that I do throw an error and that I get the expected error message when that happens. Maybe I missed it. Is that available in Assert or Julienne?
Oh, so you want to test that an error is thrown in a particular case?
Yes. Yeah.
That is something that I have done. I've written compiler tests to do that exact same thing. So I've thought about this process in a completely different context. I have not thought about that process for Julienne. I don't know if Damien, if you have.
So first, I guess I want to be sure I know what you mean. So in C++, you can throw errors. We don't have the same concept in Fortran. So I'm not sure what are you.
Well, it'd be like, so an example, if I had something where I had like an error stop, like, I have some logic and I get to error stop.
Yes.
And that's expected in that case. Like, is there a way to test that in the framework with
there's not really a robust way to do it. This is actually a big debate of ours. The library that Kate mentioned, Caffeine, it's the Tori Fortran framework of efficient interfaces to network environments. It's designed to support the parallel features of Fortran compilers. So the users of Caffeine would be compiler developers. And so error stop is actually one of the parallel features, because if one image executes error stop, then all images have to stop. So in that sense, it's a parallel feature. And we have some robust discussions going around like how to test something that intentionally error terminates. And let's just say the solution that I came up with is not popular with others in my group, and it definitely needs to be improved. So, but we're open to suggestions. So if that's something that you'd like to do with Julienne, definitely download it, start using it, and let us know, and we'll work with you to make it happen.
Okay, great, awesome, thank you.
Thank you so much for the question. I had forgotten about that example in caffeine. Yeah, where we're trying to.
I'd say that the biggest problem is that, well, there's several problems. One is that because Julienne itself is written in Fortran, if you stop, then you're stopping your test suite, right? We usually build, as Kate showed, with FPM. FPM, if you put a bunch of main programs in your test directory, FPM will run all of those main programs. So one thing is it could be a separate main program from the rest of your test suite. But then there's the question of how do you detect that that program error terminated? And that gets into issues with the Fortran standard and operating system specific issues. It's kind of tough to we haven't quite gotten there. Possibly, I mean, you could certainly mix. You could use, so we use FPM to run our test suite, but you could run the test suite with, say, CTest. In which case, I think you might have better ways to do what you're describing. That would hopefully be more like portable across platforms. That's a guess.
Other question?
Yeah, thanks for this overview. It was very clear and pretty interesting, so appreciate it. I guess this isn't related to the two libraries you were talking about, but since you did that broad overview of the Fortran landscape at the beginning, I think it's fair game.
Yeah.
I'm just curious what your perspective is on the current sort of open compiler landscape, because LLVM Fortran or Flang is it seems like where all the momentum is, but still run into compiling issues with it. G Fortran's always around. I just heard of L Fortran last year, and I thought it was just for Jupyter kernels, but I guess it's a full compiler option. So yeah, what are your takes?
Yeah, we talk about this a lot, so we have takes. And it's a very dynamic, as I said earlier, very dynamic environment with compilers in Fortran. So our takes just a couple of months ago are actually quite different than our takes now. I would say that maybe half a year ago, we were heavily reliant on needing to use G-Fortran in a lot of our projects. But then also because of various, architecture requirements and stuff, we do sometimes need to support Intel and of course HP Cray. And then we are very familiar with various bugs that those compilers have. So depending on the project, we just have to get very granular about using preprocessor macros to make sure that we're supporting the compilers that we need, but working around known compiler bugs. And of course, we want to move away from that and have code that just runs no matter what. And so more recently, where the landscape has changed a bit, is that I do think that LLVM Flang has become become more mature enough that at the moment, LLVM Flang in certain projects that we have has actually overcome G-Fortran and been able to support us for what we need. As I highlighted here, there are some specific G-Fortran bugs that we face in, again, that particular library that we don't face with LLVM Flang. Now, as you said, LLVM Flang doesn't have everything yet. In particular, one thing that we do care about is the multi-image features of Fortran, like co-array, and there is no support for those things in LLVM Flang, whereas in G-Fortran, you have open co-arrays. So what I will say, my take is that it's a very complicated landscape, and I feel like I kind of need a spreadsheet just to remind myself of which compilers are helping me with which things and which projects that we work on, because we work on a number of things with different collaborators. So it's very project specific, but I will just say that I think the outlook is very positive for Flang in the future. And like I highlighted, we at Berkeley Lab are working on Prif and caffeine. So we're trying to, our efforts for that, we're trying to help make it so that LLVM Flang could hopefully semi-soon have support for the parallel features. And once that happens, LLVM Flang might be a pretty compliant, like Fortran 2023 compiler. And I will also, this is just sort of an advertisement for the idea of if you've run into compiler bugs, please do take as much time as you have. Again, we're all busy in our work lives, but please do try to take the time that you have to file bug reports, because that helps everybody. That helps everybody in the environment, because if you're facing it, you can assume that somebody else has faced it or will face it at some time. So if we file those compiler bugs, we're helping the compilers. So yeah, and I know that that Damien would want to give his own take, but that's mine.
Yeah, sure. I'll jump in. So I've been called a Fortran evangelist. So I have Fortran on my license plate. So things that I like, I tend to be a cheerleader for. So you kind of have to take everything I say, you know, with a grain of salt, probably. But you asked specifically about open compilers. So G-Fortran, LLVM Flang, and L-Fortran. Let's see. In reverse order, L-Fortran is awesome. I love the idea of it. It's still got a ways to go in terms of supporting the more recent standards, so it's not quite usable from my perspective. But the two unique things about it, one is that you can use it interactively. So the lead developer, Andre Sertic, wanted to give people more the feeling of an interactive or interpreted language like Python or MATLAB. And so you can use it, L-Fortran, as an interpreter, not just as a compiler, and you can put it into Jupyter notebooks and this sort of thing. The second thing that's unique about it is that Andre would like for L-Fortran to be a test bed for new features. So for example, the template features that Kate talked about that aren't yet in the standard, but are several years into development, gosh, 5 or 6 years into development now, Andre has already prototyped those features in L-Fortran, which helps the committee to see what problems might come up, but also helps users if you want to try out the new stuff. So that's L-Fortran. I have actually funded a lot of the work on G-Fortran. Most of the modern features in G-Fortran, you know, whether it's type finalization or the multi-image parallel features, I founded a nonprofit, Source Free Institute, and a lot of the work on those features has been funded by Source Free Institute. So I've been very much involved in it, and G-Fortran was really my primary compiler for about 15 years. But that changed about 1.5 years ago. First of all, because we have funding to contribute to LLVM Flang. And that's maybe the main reason, but also LLVM Flang has made great strides recently. So the latest release is 20, which just came out about a month ago. And we have a lot of experience working with other people's codes, as Kate mentioned. What I can tell you is that if I just focus on what I know most people are doing with Fortran, almost all people, because, for example, Kate mentioned that LLVM Flang doesn't support the multi-image parallel features yet, but I also happen to know that almost nobody's using them. I wish they were, but they're not. So if I just focus on what people are actually doing, LLVM Flang is now the most feature complete and robust compiler that I use, bar none, like not even a close contest. As Kate mentioned, I've averaged about 1 compiler bug report a week since the beginning of 2024. In that entire time, I think I have found 1 or maybe at most 2 bugs in LLVM Flang. That's a really strong statement. Of course, here I am at this conference where I ran into Dom. I don't see him in the room anymore, but he happened to have one of the only, besides the parallel features, he happened to have one of the only features of Fortran 2003 that isn't supported yet in LLVM Flang. It's length type parameters for derived types. Turns out that something he was building needed that, and so that was missing. But it's extremely rare for me to run across a bug or a missing feature. And even for the parallel stuff that's not in well, there's kind of 2 sets of parallel features in modern Fortran, as Kate mentioned. There's the fine grain, like loop level, do concurrent. And Flang actually can parallelize those features on a CPU. And if you at least know the right fork of Flang to build, it can even offload to a GPU automatically. It just can't do it yet for our code because we tend to write pretty complicated, very modern code. And then if you look at the multi-image parallel features, that's more analogous to MPI. We've been saying the word image a lot. For those of you who know MPI, image is like a rank in MPI. So we've done a lot of work on the support for those features. Caffeine is the parallel runtime library that supports those features. We've got a lot of them implemented. We're collaborating with a company, Cyperl in France. They're doing the lowering to take the parallel syntax and produce calls into an interface that we defined that Caffeine supports. And so actually even there, again, if you know the right fork to build, like Cyprel has a public fork out there, even the parallel features, a lot of them are already there if you just know the right fork to build. But if you focus on what people are doing, check out LLVM Flang 20, and I'd be pretty impressed if you could find a bug or missing feature.
And just another note that I forgot to say about LLVM Flang, I think one of the reasons why we are very optimistic about its future is because there's a lot of the compiler, the sort of proprietary, the compiler vendors, that is to say, that are have high stakes and interest in LLVM Flang because they are already do or are planning to use parts of LLVM Flang either as their front end or back end, et cetera. So I think that's why that's probably going to continue to be one that is very important within the Fortran compiler ecosystem. So we know NVIDIA compiler team developers. We know people from ARM, from AMD. You know, a lot of these companies have a lot of interest in LLVM Flang. So yeah, if you do happen to have some code that doesn't yet work with LLVM Flang, please don't give up on it yet because there is a lot of momentum behind it. Yeah.
Yeah, thanks for all that. Yeah, I'm definitely hopeful on the vendor side because I feel like once that's more incorporated in some of their tools, we're hoping it makes them more stable as well.
Yeah. Yeah.
Thanks.
Thank you so much for the question.
Yeah, I had a question about, you said that Julienne supports the co-array image testing, and Damien just said that nobody's using that, including my project. Does Julienne support MPI, or would it have to be in co-array?
Yes. Right.
So when we say it supports the parallel features that are intrinsic to Fortran, what the main thing we're getting at is the part where Kate said a test will only be reported as passing if it passes on every image. We don't do anything in that regard for MPI. So I think I haven't tried it. I think you probably could use Julienne with MPI. You wouldn't get that specific feature, which I guess, you know, is probably a pretty important feature.
Yeah.
One of the big problems is that we do most of our work with FPM. So FPM is one of the things I'm a cheerleader for. Like, I just absolutely love it. Nothing's perfect. One of the problems with FPM is there's no way to have optional dependencies. So if we start supporting MPI explicitly, there's no way to make that optional. So then it becomes hard to build any project that doesn't use MPI. So we're kind of just like embracing the idea that Fortran has its own solution for all these things where everybody's using MPI or OpenMP, and we're kind of just going with that because there's not as much support for that as there is for the existing solutions that have been around for a long time. I guess that was a very long no, sorry.
But for FPM in general, you can have FPM projects that use MPI.
Okay.
It's just like Damien said, it can't be an optional dependency. You will always have to have MPI being built with your code if you have an FPM project with MPI. So yeah, so theoretically you could have Julienne then run tests for that project, but the output would look different, as Damien said, than if you were using the co-array features.
For a project that I was doing that required MPI, then FPM would still be okay because it's a required dependency there as well.
Yeah, FPM would be able to compile. Yeah, FPM can absolutely compile MPI Fortran projects.
And the code that I'm talking about where I'm saying it'll only report a pass if every image passes, the whole code where that feature is implemented is like 100 lines. So we could come up with an alternative for that 100 lines that uses MPI instead of Fortran's parallel features. It actually wouldn't be that hard. So just reach out to us and work with us.
Okay, sounds good. Thank you.
Thank you for the question. Okay, well, if there's no more questions, then I will say that we are on a break now and that I believe we will return at 3 p.m. Thank you.
One additional logistic piece, we are planning to have a group photo during this longer break we have scheduled. So if you can meet us out in the lobby, we'll coordinate that. Thank you. And if you're online, if you want to turn on your video feed, if you're still online, obviously if you're on break, we're trying to do a group photo, but your names as squares is probably good enough too if you already took a break. But see you in a sec.
Hello. Hey, everyone. We're going to go ahead and get started with the last session for the day. I just want to make quick announcements. One is we will have more proceedings office hours. If anyone needs help with that, that'll be from 4 to 5 today. And then also at 5, folks will be meeting in the lobby to go out to eat and socialize. So if you want to do that, just meet in the lobby. Cool. On that note, I think we're pulling up the talk. Awesome. Great. So we have, and I apologize if I don't get your name right, Guoqing Ge, who will be talking about git-mega. So yeah, go for it.
Yeah, thank you. Yeah. So my name is Guoqing, and I'm from Series CEO Bodo, working at the NOAA GSL. So I'm a data simulation scientist, simulating all kinds of weather observation for NOAA operational models, and such as RABHO and RFS. So today I will talk about a product from the developing the operational models. So the title is Promoting Open Science, a better tool for volume controlling mega binary data, git-mega. So this is a framework outline my talk. So first the motivation, and then we talk about why current product does not meet our needs, and we talk about why traditional data management is not enough. And then we talk about some details of git-mega and provide a quick example, and then show how we apply it to the UFS-based Rufus workflow, and finally summary and future work. And the motivation, and in recent years, and the drive towards open science has been gaining momentum, with researchers recognizing the importance of transparent and accessible data sharing. However, volume controlling large binary data files has remained a challenge hurdle. And as example, so NOAA have been developing a community-based coupled comprehensive Earth modeling system called UFS, United Forecast System. And in this system, we have a lot of fixed files such as terrain, surface, soil, vegetation, etc. Those data are critical for UFS application to work correctly. And these data do not change rapidly as we did with as source code or scripts, but they still evolve with time. So here I use an example from the Rufus version 2 we are currently developing. So this Rufus version 2 is a collaboration work between GSL, EMC, and other partners. And for Rufus version 2, we use MPass model and the JEDI data simulation software. And these slides show the model domain. So left side is a large North American domain. So that's a huge domain. So the fixed file should be very large. So right now we cannot handle that in our current computing resources. So we use a smaller domain that's called 3 kilometer. So for this domain, we have 2.3 million cells. So we have a lot of fixed data. So on the bottom of this slide, I listed the directories under the Rufus workflow, the fixed directory. We can see we have bomb localization files, we have CRTM, and we have mesh files, that's static files, grid files, vegetation, and orography files. And we also, for each model configuration, we need to have a static BC files. So right now, the total fixed file is about 289 gigabytes. So another thing is that in this Rufus version 2 system, there's one component that is called ADAS app. So ADAS app is a wrapper of the JEDI framework. So we can test the standalone cases. So in ADAS app, the fixed file right now is about 784 gigabytes. So the fixed files are really very large. So before I move forward, I'd like to get a comment on the same page what's a fixed file in the Rufus workflow. So according to the NCO implementation standard, so a fixed file is a text file or binary file which seldom changes its content during the lifetime of that system in operation. So in that sense, we can check our Rufus version 2. We can see that. So this example I screenshot from our GitHub repository. So we can see for meshes, we have some text files. So these text files define the vertical grids of roof's version 2 system. And we also have like orography data, like invariant data, static data. So these are binary files. So fixed file is a combination of text files and binary files. And what makes things more challenging is that in our development process, we often change our model domain. Even those are slightly changed, we need to create a new set of fixed files. Like we need new grid file, static file, invariant file. So I think since January this year, we have changed our model domain 4 times. And so that means we need a 4 set of fixed files. And at the same time, we need to keep to be back compatible so that some users still use our previous domain, they still can run their experiments. We cannot say you need to stop your experiment, you have to use new domain. So that means we need to track the change of fixed files. So I think the answer is the need is very evident. We need to track the change history of the fixed file so people can go back to any version of the rules workflow. And as we see, fixed files have some normal text files, and those can be easily handled by Git itself. The challenge is how we track the mega binary files. And we have a meeting for UFS data management meeting on February 2023, and a lot of people bring out a lot of requirements, and I think all of them are good. And I summarize them to one sentence that is we need to track binary files similarly as text files and integrate with the repository itself seamlessly. So now I'll talk about why Git-LFS. We know Git-LFS can track binary files, but that does not meet our UFS needs. So I give you a situation. So we have 2 teams, Team Red and Team Blue. Each team have a lot of members. They work at 2 different HPC. Like in NOAA, we have 1 in Boulder, 1 in Virginia. So, and they have repository, each have a lot of binary data. So here's the question: do we want each developer, each member to copy those 500 gigabyte data for each Git clone? I think the answer should be evident. We don't want to do that. So, but Git-LFS will do that. So that will cause a lot of problems. Like you have a lot of, it will cause network traffic jam. You know, take too long to clone, even clone the repository, and it will take a lot of disk space. And if you host your binary data on GitHub, it will cost a lot of money. And I think some people may also know we have another tool called the DVC, Data Version Control, and that's mostly designed for AI projects. And to be frank, I was not aware of this tool back in late 2020 when I developed git-mega. And if I have time, I compare the difference between DVC and git-mega at the end. And then I talk about why traditional data management is not enough. I think right now a lot of people understand that, because for even you use data category or even you timestamp fixed files, it will not keep metadata. You cannot track real change history, and you cannot integrate that with your repository. So that's why we developed git-mega. So the general idea is that we can see for normal Git space, we have a lot of small text files and have a lot of large binary files. So that's the normal Git space. And now we split them into 2 parts. One part is the regular lightweight Git space, and then we put all large binary data into the mega space. So that's the real content of the binary files. And then we'll put the links in the lightweight Git space. And then we use this SHA 512 hash to name these binary files so that we ensure for data integrity. And then with that, users can choose how to transfer, archive, or backup binary data by providing their own download or upload plugin scripts. So these will allow users to leverage their existing investment like data transfer archiving services such as local disks, HPSS, FTP, or AWS. And also, git-mega introduced a local mirror concept so that multiple users in the same HPC only need to share one single copy of mega binary data. So these slides show the concept of that. So right now, we have 4 users each mega clone with the repository. So that's the regular Git space lightweighted. And then right now for each mega space is now also lightweighted. And it's just a link, and that link point to the real data location. That's a local mirror in each HPC. So, and then the then you can use upload and download plugin to get data or send data to the final destination. That's either HPSS or AWS. And the important thing is all these things is transparent to the users, so you don't need to know the detail of this. They just use this tool just as use the regular Git. And then here's a quick example. So first, you need to type command git-mega deposit your data. So that's your binary data. So this step is not a must. If we don't do this step, so this step will do this, will deposit that binary data into mega space. But the problem with your git add, the problem is you don't do this explicitly. That is that because we use filter in Git to filter binary data. So if you don't do this explicitly, you will check this data twice. Once git add, and then when you do git status, you will check this binary data again. So if you do git-mega deposit data first, so that will save you some time. So that will make you things a little bit easier for you to do other Git operations. So once you deposit the binary data in the mega space, you can do normal things and git add, git commit, and git push. And the final step, you git make upload. So we'll upload the data to your final destination. And here show the screenshot. We apply this one to the root version 1 root workflow, and right now we also use that for root version 2. So a summary and future work. So we develop a tool which can version controlling mega binary data files, and it solves the problem I mentioned in the team red, team blue problem. We don't need every user to download the full copy of those binary data. So they can share one copy on each platform. And this interface is written in Bash. It has very minimum internal dependency and easy to use and run fast. And the current version works well for our root workflow. And some possible future work, right now we only add the download upload for HPSS. So if we have AWS resource, we can add that. And we may add parallel processing. So especially at the initial time, if you add 100 gigabytes into the repository, that take a lot of time to check each file to deposit that into the mega space. So it would be good to add some parallel processing. And then we may add some utility such as prune the large binary data space. I think we still have a few minutes to talk about git-mega DVC. So generally, a git-mega DVC is very similar. So there are some different. So git-mega written batch, so we don't have the Python loading overhead. DVC is written on Python. And we specially designed git-mega for HPCS, and DVC, I think that's native for when you do AI ML work. And git-mega, the whole framework is simple, and it works for our current rules workflow. And the DVC is complicated and at the same time is powerful for AI machine learning needs. And I have one interesting observation is that for software engineering, they adopt new technology very quickly, but for scientists, they really want to need to focus on science. So even I introduce the git-mega to our scientists, they still have a lot of learning curve to use that. So they think if they don't need to use that, that'd be great. So they don't want to learn a new technology. That just if they don't have to do that. So that's why we have some middle ground. So right now we adopt the two-level fixed file management. So for regular users, they just create a link and that point to a central location. And then the fixed file managers, we have 4 fixed file managers. Then fixed file managers can deal with the real content. So we use git-mega to track this directory. And then for regular users, they just create links. So we have, using these two-level fixed file management, most of the users do not need to bother with learning a new technology. And only the fixed file manager need to deal with git-mega. That's all I have. Thank you.
Great, thank you. Looks like we have a question online from Sam Rabin. Is there a way for a user to check whether a given file is available in the megaspace without downloading it?
Yes. We have tool in git-mega. We can do that. I cannot see the slide.
Oh, well. Okay, I'm going to assume that answers his question. Sam, I guess you want to post if it doesn't.
Does that answer your question? Sorry.
But we'll see if he posts. I also had a question. Well, first, any questions in the room? Nope. Okay. I had a question. If I want to like install git-mega on my own system, obviously I'd have to bring in like the bash code and put it in as a git plugin. Do I have to do anything to set up that local mirror as well? I apologize if I missed it. Or is that kind of automatically done by the bash script?
Yeah, so you need to specify a directory for your local mirror.
Okay. Okay. Yeah. Anything else? Quest. Great. All right. Let's thank Guoqing. Appreciate it.
Thank you.
Our next speaker is also online, and again, apologies if I mispronounce. Sarav De Shuvo, who will be talking about automating data processing.
Hi, I think you can see my screen.
Yep.
Yep. Hello everyone. I'm Saurav Shuvo. I'm a second-year PhD student at The Ohio State University. So my work is actually, I work a lot with warp simulations and those things. First of all, I'm not a software engineer, or I don't have a background in computer science or software engineering or anything. So it's a bit nervous for me to talk about, but I'm going to do it anyway. So like for my work and also the work that other atmospheric science students or researchers do, we use a lot of ASOS data for validating simulated results. And this is kind of what it looks like when you download the ASOS data from this website. So it's got a bunch of different columns. Like this one is showing the stations, this one is for the time, and the time I'm a bit irregular. Like this one is like 0:52 hours. This is again another different station at 0:53 hours. So this goes, there are like different variances, and then also latitude, longitude, and then different variables like temperature, dew point, relative humidity, so on. So whenever we do want to do analysis, we do need to do all sorts of cleaning and sorting. So it takes a lot of time. So I've figured out why not try building a library or a Python-based system out of it so that others can benefit, not just me. So that's kind of what behind the motivation behind this work. So as a preliminary stage, I kind of added these like sorting by date and time, sorting by station, sorting by variables. And the last two, you may not always need it, but I found it useful, so I added it. So sometimes you may have duplicate entries, you want to remove them, and sometimes you get different files have different date time formats. So you want to have a unique one. So this is there for the user as well. So the first one, sorting by date and time. So we will work on with the column valid, that has the date and time information for that particular station and that particular variable. So, and we will round it to the next hour, as I showed you previously. So they do have differences in timing. So I found it like useful to round it to the next hour because most of them are like taken very near to the hour. So it makes a lot of sense rounding it to the next hour. And then all the files, all the information is saved in for the time, like I renamed the file using the time information from those valid column and save it there, so it's easier to access or found whenever you do need to use them for analysis. So this is kind of what it looks like after you run through the code. And if you look inside of a file, this is kind of what it is like. This one is valid at 2 UTC, and you can see them timing are like very near to 2 UTC. Not all of them are exactly equal to 2 UTC, which is very common. So so this is the first sorting. The next one, this is the easiest of all the 5, is like sort by station. So this kind of takes in the station column and just group it through that station column and just go ahead with storing them in individual Excel files. So if I take for like GFK stands for Grand Forks, North Dakota. So it has all the information for Grand Forks. Now, keep in mind, this is sorting by stations, so it should have different time information. Obviously, you can do both together. Like if you want to store like for station and then time, you can do that as well. But I'm just going by one. The third sorting is sorting by variables. So as I showed in the initial file, there are like quite a different variables, and most of the time, this is the sorting that I do. So this is like sorting for all the variables. Now, in all the files that we will be creating after all the sorting is done, I want to keep a few columns as very common and name them as base columns. These are like station valid. Valid is for time, longitude, latitude, and the elevation. And each time the new file that's been created, one of these columns will be added according to the variable that I want to select it or sort by. So for example, like if I'm taking temperature, so alongside this temperature column will be there. I'll show you what it does. So this is what it, just let me go through this code. So it's just does takes one of the variables and then the base columns and then just runs through it. So that's what it creates. So it creates separate folders, and inside of it is like, for example, this is inside the temperature files. And this is what the temperature file looks like. So you see all that's been cleared off. So this has only the temperature for all the stations and for all the time. Obviously, as I said before, if you want to do more sorting, like sort by time and sort by station, you can do it all together. Now, this is, as I said, this is very uncommon, but sometimes we do get duplicate entries in the files, and it's really annoying to work with. So what I wanted to imply in the logic is like for like these columns, like station, valid, longitude, and latitude, if there are like two consecutive rows with equal value, then obviously that's duplicate, and I want to get rid of one of them. In which case, I actually want to get rid of the second one. So I want to keep the first one because I deem it to be the original value. So this is the logic that I implied in writing the code. So, and the other thing is, you can see I added a few print statements just to see what the code is actually doing. So like if it finds a duplicate value, it actually shows that which file and which folder it is actually working with, so that you can actually see what it's deleting. So I find it very convenient, so that you don't get to mistakenly delete something that you actually need. And the other thing to look at is actually whenever it's finding any duplicate entries, it's not, whenever it's cleaning the files, it's not creating a new file. It's actually keeping the original file and only deleting the entries. So that's convenient in a sense that it doesn't eat up a lot of space in your computers. And the final is the fixing the date time format. So this is also sometimes, this is not always there, but sometimes we find that the valid column has different date time formats. And whenever you're doing a comparison or you want to do any sort of statistical analysis like RMSE, and if you want to keep the time information as the base, so this also causes some issues. So what I did was, if such is the case that there are like different datetime formats, but you don't know, obviously, when you open a file, like the original file could be multiple days and multiple hours for numerous stations. So it should be a lot of rows and columns, and it's difficult to gauge through all of them and to find like where there is a difference. So the first thing that I wanted to do is like, okay, find the formats if there are any differences in datetime formats. So the first thing that these two functions do together is like, the first function is like detect a format. So I wrote down all the different formats that's actually I've seen. There could be more. I haven't added them, but I could add them. I will add them if I see them. So what it will do is like detect a particular format, and this one would the list date format would actually list out all those formats. So you can actually take a decision whether you need to fix it or you don't, because it may be a case you don't have differences in datetime formats, so you can go ahead with your analysis. But if it is there, so you can actually like fix it if you want. So that's the third function, standardized datetime format. So what it will take is like all these functions, the three functions that I've talked about, they will work with the valid column. They will actually create a temporary column uh, which is like original valid, and it will put in the date time that it sees in the file, then compare between the two, the standard format. I've actually gone with this one purely because like I said, I work with WRF simulations, so WRF kind of lists the date time information in this format. But obviously, you can change to whatever you want to show. So then the valid and the original valid, it will make a comparison. It will see if it is in different format and then transform it if necessary. So this worked out well for me, but obviously you can change in your way or whichever way convenient for you. So all right, so after all those like date time thing, you can see now it's in the equal format. This is just one file that I show, for example. So finally, after like whenever you have done through this, I've said like I would want to make a Python library for everyone to use. So, and even like I use it now. So this is the library that's I've made and it's available. You can scan through this code and this will take you there. You can install and work with it. I've actually detailed more example in there, so you can easily go through and work with it. The link is there if the QR code doesn't work. And also there's a Git page. I've set a Git page for that. Again, the link is there. The QR code is there. You can scan through it and get working. And yeah, that's just about that. Thank you.
Any questions in the audience? Well, I had one, and maybe you actually covered it at the beginning, but I missed it. So is this, so yeah, you have CSV or Excel spreadsheets, and then you're reading them into Pandas, and then is it just kind of right now, is your package just save it there, or is it like writing output files? And
Yeah.
what is the format of those output files?
Yes. Sorry, I actually should have explained that. So it takes in the CSV file and gives you output into newer files. And in some cases, when like the third sorting that we are doing, sort by variables, it will create individual folders and store the individual Excel files inside the folder. So in the first three sorting that I showed, like sort by date and time, sort by variables, and sort by stations, in these three cases, it will create new folders and store the new Excel files within there. So nothing is happening to your original ASOS data file. It stays the same, all true. But after all the sorting and all the decluttering, your newer files will be the ones that gets changed.
Great, thanks. Any other questions? Yes.
Yeah, great talk. So are you running this in real time to collect data all the time? So is it every hour or something like that, or what's the scale of how often you run it?
I believe you're asking like if I can download the data with this code, right?
Yeah, I mean, so is the use case that maybe you only need to do this for select days of ASOS data, or are you collecting the ASOS data all the time, like every hour?
Yeah, actually, this code is developed to work with ASOS data. So this code doesn't really download the data for you, but if you happen to have a ASOS data file, then you can do all the sorting and
Okay, yeah,
cleaning that you
yes.
can do. But the ASOS data, it's the link that I showed in my slides. It's very, very easy to download ASOS data. So
Yeah, it's from you linked the Mezzo West site
yes,
or
yes.
okay. Yeah, great. Thank you.
There are questions? Okay, great. Let's thank Saurav one last time.
Thank you.
All right, and then our final speaker who will be here in person, Samuel Akinjole. All right. Who will be talking to us about Geoschem Hyperdual.
Yeah, I'm sure we're excited. It's the last session for the day. Good day, everyone. My name is Samuel Akinjole, so you got it right. I'm a PhD student in Drexel University, working with Professor Shannon Karps. And basically, I'll be introducing the development of Geoschem HYD, which is the Hyperdual-Step method that was introduced by my colleague Jiachen Lui in the morning session. Just the developments on Geoschem, which is a global atmospheric model useful for tropospheric and stratospheric chemistry. Okay, it's working, yeah. So just as an overview, so sensitive analysis quantifies how different inputs, for example, your parameters, your initial conditions, influence a model's output. In chemical transport models, for example, like Geoschem, it describes how changes in input variables, for example, your emissions of select species, affect your output variables, for example, your species concentration. But the main takeaway is that with sensitive analysis, we can we involve a systematic way to find what really matters in a model or any complex model of your choice, helping you refine both the design and decision making. So for example, with an atmospheric model, it helps guide policy decision makers who use chemical transport models for different processes. So the idea is that if we recall the brute force method, which is your final difference method, here I have a flowchart to describe it. You have two different model runs. You have your default inputs, you have your model run, you have your forward perturbed input, and you have your model run, and you have your default output, your forward perturbed output, and then you do your post-process sensitivity calculation, which you just take the difference divided by the perturbation size to get your first order sensitivities. Likewise with your central difference method, where you have a backward perturbation and a forward perturbation, you run your model, you take a post-process sensitivity calculation and you get your first order sensitivities. Even though the central difference is more accurate than either your forward or your backward, it still involves a truncation in the second order term and still involves subtractive cancellation errors, which I'll still talk in a bit. But basically, for final difference, you have more model runs, including post-processing, which are required for the sensitivity calculations. However, with the Hyperdual method, you only need to run the model once. So you have an HYD input, your Hyperdual inputs, you have your Hyperdual model, you get your default outputs, your first order sensitivities, and your second order sensitivities with one model run. Now, this is the motivation behind using the Hyperdual-Step method, in addition to the accuracy it provides, so you can get both numerically exact first and second order sensitivities, in addition to your default output values. So for those not familiar with Geoschem, again, like I said, Geoschem is a global atmospheric model, which is useful for tropospheric and atmospheric chemistry. There's several applications to Geoschem. It's used in equator modeling. It's also used in global atmospheric composition. So if you want to run models or run the transport and chemical evolution of various species, like your ozone, your PM2.5, or other criteria pollutants. So useful in climate chemistry interactions, for example, radiative forcing, where you have to assess how gas and aerosol affect the Earth's radiation balance. It can also be coupled with other Earth system models like your CSM. It can also be useful for research purposes, where you're trying to investigate, several processes like your aerosol cloud interactions or other processes of interest. Now, here I want to demonstrate how we went about implementing the Hyperdual-Step method in Geoschem. So first, we need to understand the Geoschem code structure. So here's a typical outline of a subroutine within Geoschem. So basically, you utilize both state variables and your local variable declarations. The idea behind making a model Hyperdual is that I want to change specific variable types to a Hyperdual type. And in doing this, we had developed a Hyperdual overloading library, htmod, which you can find in this link. The idea is simple, is that we include the model using the use command. So use htmod. Htmod is the model that contains the overloading operations. We convert specific variables to a Hyperdual type. So basically, you have a subroutine, for example, you include your htmod library, use htmod, and then convert variables to type Hyperdual from real precision, either double precision or single precision or any other precision of your choice. And here's a simple example I wanted to show. So basically, for this model, FullChem-Mod, we included a Hyperdual library. We converted some variables, not all variables. You could actually convert all variables to a Hyperdual type, but this can incur a significant computational cost. But the idea is, if you want to observe certain relationships, you just start with the relationships that you're interested in, convert those variables. So let's say you're starting with emissions, you convert emissions to Hyperdual type. The variables that depend on emissions, that propagates from the emissions to your final output type, like your constitutions, you make those changes sequentially. And this was, like I said, this was done with the overloaded operator, htmod. So basically, the htmod library overloads operations, your addition, your subtraction, your multiplication, other operations that are within your model. Here I have an illustration of the htmod library where you have the subtraction operation. So you have your first operation, which is going to be your real operation. So your difference operation for the real part. Then you have your first order sensitivities. Your DX1 and DX2 contain information of your first order sensitivities, and your DX1 and DX2 contain information of your second order sensitivities. Further operations were added to the htmod, which are specific to Jiachen. Most of these operations were just array operations, so high-dimensional operations like 3-dimensional, 4-dimensional operations were added to the htmod library. So I created a flowchart to just describe the Jiachen model in general. So you have your inputs, your initial conditions, your Hempel emissions, your methodology. You have the processes within the model, your chemistry, your cloud convention, the data deposition, and other processes. Then you have your outputs, your species constitution, and other outputs. So the idea is, we want to start, what are we trying to answer? In this case, we're trying to explore how emissions contribute to concentrations. So we start with your Hempel emissions. We change variables that are relevant to the Hempel emissions. And those variables that depend on the Hempel emissions are now changed in the processes before your final outputs. So you include your htmod library, you change variables within those Hempel emissions, you change the processes, so subroutines that have those processes depending on the emissions, like your chemistry calculation, doesn't have to be all the processes. And then you can get additional outputs, your first order sensitivities, your second order sensitivities, in addition to your default concentrations. So another thing that I wanted to point out was, you could also optimize your model. In this case, for Hyperdual calculations, which follow forward mode automatic differentiation, where the sensitivities are calculated at each line of code. For Jiachen, we notice that some of the routines can be unstable. It might not be as, so Jiachen is like a complex model compared to like a simpler model. But for example, aerosol-thermodynamics equilibrium model, Assert is numerically unstable in some instances. In those cases, we can actually make certain variables real for stability, especially when these variables have minor contributions to the sensitivity calculations. We made the calc function in Assert and the rate constant gas phase chemistry real. The sensitivity calculations from these operations remain accurate, which we'll illustrate with the next slides. So in terms of the testing and application, we worked on the version 14.00 RC2 plus the rad pressure fixer, and this was done in a 4x5 spatial resolution over a 24-hour simulation over July 1st to July 2nd. For the application, we did it over a week in August, which I'm also going to show in the next few slides. We compared the HYD to the brute force method, and we can see on this plot here, your y-axis is your HYD, your x-axis is your final difference. We can see that the one-to-one plot for your seminal light sensitivity of NO2, which is your left, to your NOx emissions, which is your left plot, shows good agreement with the final difference. Likewise, your seminal light sensitivity of ozone concentration with respect to your NOx emissions also show good agreement. We did that for several other species your gas-phase species and also your secondary aerosol species. One thing to point out is that, remember I said the finite difference method suffers from subtraction and truncation errors, so you need to actually determine a perturbation size that could produce accurate sensitivities. And we notice that for the secondary aerosol formation, where we can see some discrepancies in like PM2.5 and ammonium, which can be attributed to having to determine an appropriate perturbation size for the sensitivities. Yeah, I just wanted to demonstrate some results. So basically, like I said, you can get your default outputs. In this case, if you run a global atmospheric model, you can get a constriction over a time span. So in this case, I have a 1-week simulation run where you have the model output for your ozone constriction over a 1-week simulation. So the constriction changes depending on the presence of sunlight and precursor constrictions. The real values for the Hyperdual code remain the same in comparison to the base model. So if you run a base model, you still get the same output if you run a Hyperdual model. But the beauty about the Hyperdual-Step method is, one, you can also determine your first order sensitivity in addition to your default output. And here I also have an illustration, the GIF illustration of over a 1-week period where we know that tropospheric ozone is a secondary pollutant formed by the photochemical reactions of nitrogen oxide and volatile organic compounds in the presence of sunlight. However, why we included this, I wanted to demonstrate something that you can also use with first order sensitivity. So if you look at the East China region, so this part, which is an industrial region, we can see that in East China, there is a negative effect at certain times of the day where you have more NOx being available than your VOC concentrations. So here we now have a titration of ozone by NO, and the reaction follows NO plus O2, giving you NO2 plus O2, which in turn leads to a negative effect on the ozone concentration, as you can see over East China region. Again, we can also determine the second order sensitivity, so semi-normalized second order sensitivity of ozone to NOx emissions. And we can see over the time span of the 1-week simulation, the second order sensitivities are negative, which suggests it's more of a concave downward relationship rather than, which helps us avoid overestimating the contributions of NOx emissions to ozone concentration or any parameter, any input parameter to an output parameter. We can also go a step further and have another species of interest modeled, your concentration, your first order and your second order. In this case, I have for ozone to isoprene emissions. And we can better illustrate the NOx VOC ozone chemistry, whereby if we look at the East region, the East China region, again, we can see that the isoprene emissions to ozone concentration are mostly positive throughout, but these are of less magnitude compared to the ozone to NOx contributions, which suggests this is a VOC limited region. And for a VOC limited region, it means that when you have more NOx available and less VOCs to react with, then you have that net effect that we have explained earlier in those certain time of the day due to more NOx being produced. Overall, the first order sensitivities show positive relationship for your NOx emissions to ozone, but second order show negative relationship, which again shows as a concave down. For your isoprene, in general, large isoprene emissions does not correlate to higher ozone. You still need contribution of NOx. So where we have NOx concentration being significant, we have positive contributions for isoprene, and then where we have less NOx concentrations, we have a negative contribution for isoprene emissions. The second order shows mostly negative, which again shows a concave down relationship. Now, like I said, there are more operations. We evaluated the computational cost for each process. Like again, you can be specific on which process of interest. Here I have the base model in comparison with the HRD model for a perturbation of NOx emissions. And we can see that most of the computational overhead occurs from gas-phase chemistry and photolysis, again, because of the gas-phase chemistry with NOx emissions. But overall, the model is about 3.9 times that of a base model run without your sensitivity calculations, which is still pretty good, if you ask me. Yeah, like my colleague Ed has explained earlier, we created a hyperdualized SPI, which can be useful if you want to hyperdualize your code, especially if you are working with Fortran code, which you can have in this link. And overall, I want to thank the NSF Career Fund for the sponsoring this project. I also want to thank the NCAR High Performance Resources, which I use to run most of this model simulation and the results. Jiachen Liu, who's my colleague, who did most of the HTML development, and then the registration and travel support from the ISS conference committee. So yeah, thank you. And do you have any questions?
Great, thanks, Samuel. Any questions in the room? Okay, I guess I have one. So you mentioned that sometimes there'll be certain applications where it goes unstable and you have to put it to real. Is there any way to kind of guess at that a priori, or do you kind of just have to do trial and error and then?
Yeah, in this case, it was mostly trial and error because you can't really tell. I mean, it's possible if the code is discontinuous, then you could probably tell like maybe there could be issues that could arise, but really it's mostly a trial and error situation right now. Yeah.
Thanks. Cool. All right. Well, let's thank Samuel one last time. And it looks like that is the end of today. So again, just more reminders. There is a proceedings office hours today from 4 to 5. And then at 5 p.m., folks will be gathering for a social. So, all right. Otherwise, thanks, everyone. And I will hopefully see you tomorrow. Thank you.